Hello, everyone, and welcome to Sub0 Online 2021. My name is Bill Laboon. I'm the Director of Education and Community at Web3 Foundation, and I am really excited to show you everything that is happening right now in the Substrate ecosystem. We have many great presenters from Parity, from Web3, and others developing with Substrate. Before we start, though, I do have a few just housekeeping tips to go over. First, for those of you watching on Hopin, please make sure to go to the reception area if you want to see the schedule for today and tomorrow. As a reminder, today's schedule, there's a single track. However, tomorrow there will be 3 stages for beginner, intermediate, and advanced. You can always click the stage tab to see the sessions that are currently live. And you can use the Q&A section on the right-hand side of the screen to either ask questions or upvote ones that you would like to see answered. And after the discussions, I will pick some of these questions and ask the presenter. After the presentations, you can go to the Discord with in-depth discussions with speakers, many of the speakers after their presentations, or just to discuss other Substrate-related things. Also on Discord, we've set up a job board. So there are some open positions that you can check out, or if you're a Substrate-based project, then you can post your own. Finally, as a reminder, during our breaks, there are a few throughout Sub0. Please feel free to join the speed networking sessions or just sit back and enjoy the music. After the end of the first day, we'll have some swag giveaways during the final networking session at the end of the presentations today. So without any further ado, I would like to present Dr. Gavin Wood.
Thank you, Bill. Good. Thank you, everybody, for tuning in. It's still a bit of a shame that we can't all gather in person like the first couple of Sub0s, but you know, I have a lot of faith that next year things will be a little bit back to how they were. I'm going to use my little bit of time up front to talk to you. I'm going to cover 3 things. First, I want to just reiterate what it is that we're trying to do with Substrate and with the Parachain model that Substrate was made for. Second, I want to talk a little bit about what the status is of some of the Substrate-related projects that Parity is working on. And third, I want to talk more broadly about some of the currents that we're seeing in the industry at present and how that relates to Substrate and Polkadot. So yeah, let's start with a little bit about like what Substrate and particularly the Parachain model is for. This came up a bit in the last few months with a you know, with our industry heating up with a few new projects on the block, and a clear idea of what it is that Substrate gives, I think, is always worth to have in mind. So Substrate built Parachains really have these 4 very important attributes, and we've got to really I want to dig a little bit into each one so that everyone here is very clear about why it is that we're doing what we're doing. Unstoppable, upgradable, unlimited, and feeless. So let's dig in a little bit. Unstoppable. So Substrate-based parachains and Substrate chains in general are crucially, they're very decentralized, right? Now we can compare this to a lot of other projects that are not really designed to be that decentralized. They're designed to be a bit decentralized. I suspect that the project leads often a sort of trying this hybrid model in order to see just how close they can get to the regulators before they're determined to be just too centralized. But with Substrate, we really want to live the true peer-to-peer dream and make something that is actually unstoppable, which is why, you know, all of the nodes are full nodes sort of have all of the data, why validators, why it's easy to become a validator on a Substrate network, and why we are dedicating a lot of effort to ensuring that light clients are not just viable, but also efficient and performant. So we are trying to achieve scalability with decentralization. We're not going to trade off any decentralization in order to get some initial bit of scalability. The next thing I want to talk about is upgradability. Now, most of you will, this will be old news too, but I think it's nonetheless very important to emphasize that this is a key feature of Substrate and Polkadot, and something that we want to, we view as being like a key part of its mantra and ethos. It's a meta protocol. Substrate chains are meta protocols. Polkadot is a meta protocol, being as it's based on a substrate chain. So this allows us to upgrade, update, assimilate new technology very efficiently, very effectively. There's a couple of pictures to try and get this in, drive this home. You know, we see a lot of chains. Making those upgrades is a bit like trying to run in a very muddy field, whereas we get to be the illustrated kite surfer. A very important difference of the Substrate Parachain model is, especially as it's compared to the smart contract model. And this is a question I get asked about a lot. So it may possibly be a question that you get asked about as Parachain teams and Substrate chain teams. So I want to make it super clear. The Substrate Parachain model is a free execution model. This basically means you're leasing out a chunk of time on what amounts to a distributed CPU core. And this is a lot different. This is fundamentally different to what the smart contract gives you, which is a transaction execution model, which is essentially where users can pay to have your code executed for them. As a free execution model, you're guaranteed that you get scheduled in time slices, and you're guaranteed that scheduling happens at regular intervals, every 6 seconds, for example, for a Polkadot Parachain. And this is crucial in giving you the power and freedom in order to decide how your application should work and implement it as you need to. Crucially, you are in control of what transactions get executed, not the other way around. On a smart contract chain, the transactions are in control. And if you can't get that transaction through for whatever reason, or rather not you, but your users, then your application simply won't run. And that can be that can make a huge difference as to what applications are actually viable. I mean, the sort of things that a free execution model can give you, you know, go through them: on-chain scheduling, transaction prioritization, ordering, and so forth. In short, facilities like on runtime upgrade, on initialize, on finalize simply cannot be supported in an Ethereum style smart contract system. And that's something that you really can get very easily in Substrate. Finally, feeless. Now, this isn't quite what it's in, because of course a lot of Substrate chains have fees, but it comes in two key points. The first one is that as a Substrate-based Parachain, once your chain has secured a Parachain slot lease, then you do not have to expose the DOT token or the KSM token, or indeed any token, to your users. Now, of course, most teams will have their own tokens that they want to use in order to charge users transaction fees, and that's fine. But in principle, it's entirely your chain's decision. You do not need to expose users to any transaction fees at all. In principle, you can restrict your user transactions to some manageable amount for your chain without bringing tokens in at all. You could have, for example, certification of users. You could have an oracle that checks that the user has a sufficient, has a sufficient degree of individuality that they won't be able to Sybil attack and therefore DOS your chain. There are ways of doing this, and this opens the door to feeless applications running on parachains, and that is a very interesting path indeed, because in my mind that would open the door to mass appeal. At the moment, we can only really appeal to people who don't mind owning tokens or already have some. That's, I think, quite a limiting factor. Okay, so that's broadly speaking how I see Substrate and Polkadot, the Parachain model, deliver some really crucial and fundamental differences. The next thing I want to talk a bit about is just the status of some parts of Substrate relevant technologies. This is, forgive me, this is actually not that much to do with Substrate per se. This is more to do with Polkadot, but I figure most of the people here won't mind too much. First thing I want to talk about is the status of the bridges, very relevant for Substrate projects. This will allow Substrate teams to connect their solo chains between each other, and also if for whatever reason they are not planning on getting a parachain slot just yet, it could also provide connectivity, admittedly less secure and a bit more latent, but connectivity to the relay chains. Bridges are also a very important piece of technology for some stuff that we want to get done next year, but now is not quite the point to talk about that. So the bridges status, the bridge audit is about 2 weeks from being completed, without very many issues being found at all. This is actually, I believe, the second audit. The first one was done some months back, so this is basically the audit of the corrections. There will be a bridge being deployed soon from Rococo to the bridge testnet Rococo, just to make sure that works. But we do expect a relay-to-relay chain bridge deploying before the end of the year for Polkadot and Kusama. That assumes, of course, that the last 2 weeks of the audit don't bring in any more significant issues, but that's the expectation. And the parachain to parachain bridge hopefully deploying early next year. There will be an additional information on this a bit later on in the conference, I believe, but yeah, there's the summary. Next thing is the XCM status. So XCM v2 is delivered. It's part of Polkadot 0911. This brings in most of the core features of what we've been asked for. Asynchronous error handling. So basically, this means that you can have some on-chain code run in case of some error that happens on a remote chain. And it's done in a relatively nice way, so it's all done with dispatchables. Status reporting, so allowing the status of some XCM instruction to be reported back to some other chain, which presumably will want to register it with some code handler. Asset trapping, which is essentially just remembering the contents of the holding register at the end of an XCM message. A lot of the time, an XCM, whether it's through an error or just accidentally, with perhaps a message that wasn't crafted properly, at the end of the message execution, some assets are left in the holding register. This allows for those to be remembered and then later claimed. Exception handling, there's now exception handling actually built into the language model of XCM. We're now using a virtual machine model that's a bit more, I think, comprehensible and extensible than before. And one of the big ones is it's got version management. So this allows different XCM versions to coexist within a multi-chain network. I've also done the specification for version 2 as well. Next is the status of the parachains. I know this is of importance to many of you here. Parachains, the Parachain code is now considered feature complete in that all of the security mechanisms from the Polkadot spec are implemented, tested, and audited. So yes, the audit's complete. The corrections from the audit, about halfway done, expected to be finished by November. And we do expect a initial deployment of this feature complete security code onto Kusama very quickly. And we want to leave it 3 weeks before we would want to see it in production, but we don't expect any significant problems. So that should give some idea of the timeline that we would expect before the before we expect any parachains to go live on Polkadot. In terms of our opinion on the production status of this code, we think it's reasonable to be confident that parachains be technologically viable from December. And we think a deployment to Kusama by the end of October is something that we should expect. And so from a technological perspective, I think it's not unreasonable for Polkadot to begin preparations for the lease period 6, 7, 8, 9, 10, 11, 12, 13, for that batch of auctions to begin being prepared for more or less now. We think an ongoing auction schedule will be sensible. We think the number of parachains on Polkadot should remain up to only 3/4 of what's on Kusama in order to keep Kusama as Polkadot's canary network, at least until the code is mature and we have a much better idea about the amount of parachains and transactional throughput and message throughput that it can handle on the current infrastructure. We think shorter auctions for the initial parachain scale-up period would not be unreasonable. In general, we would stick to what we've already was published in the past, so a roughly 2-week per auction schedule. Good. And looking forward, I want to just talk a little bit about some of the currents and trends. Not very many, actually, only a couple. In the industry as a whole, and how it relates to what we're doing with Substrate, what we're working on, and what you can expect from us over the course of the next 12 months or so. One thing that I've noticed is that in the search for high transactional throughput, there are quite a few chains that have lost sight of the fact that decentralization, and for that matter, security, are not optional features, right? You can get a lot more transaction throughput if you're willing to trade off the effective decentralization of your network, if you're willing to trade off the peer-to-peer aspects of your network. There's a reason that Ethereum 2 is taking so long. Actually, there's several reasons. One of them is that they're doing it, they're not willing to trade off, as we are not, the decentralization aspects of the network. And if you're not willing to do that, then the architecture, the design, particularly that of the security, has to be a lot more thought through. So when you see networks claiming large TPS that are supposedly public networks, I would take any comparisons with quite a lot of salt. And oftentimes, it's really not an apples for apples comparison. If we look at the currents of the global regulation, we can see a few things. Now, I've read a couple reports about this. I don't claim to be an expert. I certainly don't claim to be a lawyer, But there are some things that crop up in these reports, in these policy statements, that seem, in my mind, to make some sense. If we look at the FATF, which is an international body, it's roughly the G20, I believe, of nations that get their heads together, or give some faceless bureaucrats and get their heads together. We see some fairly, if we look at what they're saying, we see some fairly clear policy. The good news is that software development and generic keeping, so maintaining of a network, is considered something that untouchable, is considered something that should be allowed to continue without any regulation at all. And this is a good thing, right? Because this is our bread and butter as developers and people who want to deploy these kinds of peer-to-peer networks. It's crucial that these activities remain free and unfettered. However, it's also pretty clear that global regulators are taking a very critical eye to some other things that I think most peer-to-peer, most decentralized projects have at least dabbled in a bit, many of which rely very distinctly on some of these. One is service provision. This is basically RPCs, wallets, app sites. Another is multi-sigs. So like DAOs are often sort of named example of this, where you've got like a bunch of named personnel who can decide how to spend the DAO's treasury. This is also the case with Polkadot Osama. Custodians, hosted wallets, and non-peer-to-peer stablecoins being the obvious two. And also, it seems easy fire is what I've called here, but basically apps, wallets that are trying to utilizing centralized mechanisms, trying to make the decentralized apps easier to use. And I think these probably one of the later things, but these will still, from what I'm reading, come under some scrutiny. The service provision is one of the most interesting ones because, of course, decentralized networks that are, I would say, fairly legitimately peer-to-peer, such as Ethereum, still make a heavy reliance on centralized RPC services, and oftentimes centralized wallets and sites to host decentralized applications. And I think these, certainly looking at the language that is being used by global regulators, it seems that these will come under substantial scrutiny in the not too distant future. One thing I think is certain: the more centralized you are, the more chance you have of regulators knocking at your door, insisting that you become licensed. And the more peer-to-peer, then the lower the chance. So pushing towards peer-to-peer seems reasonable. Another thing I think that it's quite likely, again, reading some of these documents, it seems that crypto projects that are not sufficiently peer-to-peer, that are deemed sufficiently centralized, will probably require licensing, and those licensing requirements I would expect will be of the similar kind of standard to banking requirements. If this is true, this would imply that most crypto projects in their current form may not actually be able to exist in the next year or two. I mean, I think the timeline for this is probably 2 to 3 years before it gets properly enforceable, but still, it's good to plan for the future, especially when the technology that you need to mitigate these risks is quite difficult to implement. At Parity, we are committed to peer-to-peerifying everything. We want to make sure that our technology is in line with what is considered not needed for regulation. And this means that we have a lot of emphasis now, but also going forward on these what I would call almost like weak points within the decentralization, particularly bootstrapping, boot nodes, point of centralization there. RPC nodes, also a point of centralization. We're managing that with with light clients, and particularly in browser light clients, which I hope we're going to have a nice introduction to you all for in this very conference, with governance, particularly trying to ensure that we can have on-chain decentralized governance that doesn't fall foul of any kind of potential multi-sig regulations, and also privacy, so privacy mechanisms such as mixnets. One thing that I want to make very clear is that solutions that are built on Substrate should be true Web3 solutions, so actually peer-to-peer. And similarly, for Polkadot, we want that to be the first peer-to-peer, secure and scalable free execution platform. And with that, I just want to leave you with the 4 tenets of Polkadot parachains and Substrate chains: unstoppable, upgradable, unlimited, and feeless. Thank you very much. That was my keynote.
Okay, thank you. That was very interesting, and we have quite a few questions from the audience if you have some time. So first
sure.
on this last, so first on this last topic about regulation, do you see risks to developers and like centralized solutions for development such as GitHub for these projects, or do you see it at a different level?
I think centralized solutions that are very clearly geared towards general development are probably not going to have much of an issue. I don't think they're going to start. I don't think regulation is going to start coming in against like the Rust language, because the Rust language happens to be used for Substrate. I do think that I'll continue on that thread. I also don't think that teams that engage purely in technological development, so basically in coding, software development, and software releases, I don't think are going to be a big target anytime soon. I would hope indefinitely, but I do think that any service provision that is to do with transaction facilitation, not just processing, could become a target, could come under scrutiny, and therefore it's important to try to minimize the degree to which we as teams operating in the space have any significant control over the transactions and the use of any value that exists within our networks.
Okay, thank you. A couple of other questions, 2 actually that we had that would just like to clarify some of the things that you mentioned. So you had mentioned lease periods 6 through 9, but I think some people didn't understand how lease periods work. Could you just go over what that means exactly?
Sure. That was the typo. It should actually be 6 through 13. But yeah, the lease periods are essentially time slots for parachains. So each lease period on Polkadot is 3 months, and we are currently at, as it happens, I think we're just approaching the midpoint of lease period 5. Lease period 5 should be ending, and lease period 6 should be beginning around the middle of December. And we think that basically the middle of December would be a not unreasonable point to have, from a technological point of view, to have parachains be live on Polkadot. I mean, we would actually say probably early December, but as it happens, mid-December would not be, we think, a bad plan. Okay.
Also, one of your slides, you had mentioned both relay to relay bridges as well as parachain to para bridges. So is this using XCM? Is this something different? Like, how would this differ? Like a bridge between a parachain and a parachain differ from using XCM, or is that actually part of the same thing?
XCM is a message format, and this as a message format should be usable regardless of the transport mechanism. XCM is usable both for communicating upwards to a relay chain, downwards from a relay chain to a parachain, sideways using XCMP from parachain to parachain, and also over bridges, which is another transport mechanism. The relay to relay bridge is essentially just saying that there would be actually on the relay chain itself a pallet that allowed the relay chain to send messages to another relay chain. Now these messages would be pretty secure, but in principle we may have they're never going to be as secure as parachain to parachain within the same relay chain network, just because they have actually the same sovereignty, the same consensus mechanism, the same securing capital. When I mentioned the parachain to parachain bridging, what this means is that the bridge would sit from a parachain on Polkadot to a parachain on Kusama. So it's still bridging Polkadot and Kusama, but it's doing so without interfering with the relay chain itself. It's doing it all within the confines of a single parachain. And eventually this would obviously be a system parachain or a common good parachain. And it would, in principle, should be able to hold more than one bridge. The general idea is that we would have a bridge hub that would sit in this common good parachain, bridging over to not just Polkadot to Kusama, but also Polkadot to many other networks. And similarly on the Kusama side, from Kusama to networks beyond Polkadot.
Okay, yeah, bringing that vision of multi-chain world to fruition. So another question we had is, what is going to be the focus on substrate development over the next year or so? I know we've seen, I know we're going to see a lot of things that people are working on, but would you say there are particular areas of focus that you're working on?
Yeah, so the main things I think that we're going to see are, in terms of like a renewed focus. Obviously, there are bridges. There's the continuation of some of the frame stuff, in particular upgrades and migrations. But a renewed focus will be placed on Substrate and its peer-to-peer decentralization technologies. In particular, ensuring that we have the right governance apparatus to be able to have agile, efficient, inclusive, accessible governance without relying on centralizing mechanisms like the council and potentially even like the technical committee. So I think one of the things that we're going to see over the next 12 months is a evolution and iteration in the governance building blocks that Substrate provides. A second thing would be the light client. I don't know, many of you may or may not be aware of the Small Dot project, which aims to be a Substrate light client that is very efficient and very nippy. It can be compiled into WebAssembly and sit quite happily within a browser window. We'll also be focusing one of the sort of newer projects yet to be commissioned, but soon will be the initial bootstrapping and discovery, so that we can find boot nodes for a Substrate chain without having to have them hard coded into the code base. And one other initiative that I'm quite excited about next year. It's not strictly the Substrate feature or code base, but is a Substrate and Polkadot centric education program. That's something that's in its early phases at the moment, but I would hope that over the next 12 months we have really a very world standard, gold standard education program for people who want to really get to grips with Substrate and Polkadot, parachains, blockchain technology in general, crypto, game theory, and Rust. And this is, I think, something that we've obviously got some things already in the ecosystem, but this would really be the icing on top of the cake.
Yeah, I'm very curious just to follow up on that. Do you have any ideas about some of these new governance primitives, these decentralizing governance primitives? Or this is the very early phases of thinking about that?
No, indeed, there is very much some ideas. And this is something that I wouldn't want to say that we are at the point immediately before implementation, where we have a very coherent design, but we're also, I would say, we have fairly fleshed out ideas. One of the, I think actually the main idea is to try to follow a more liquid democracy model, where we have, where we emphasize vote delegation, which is in effect what the council is doing anyway, right? So in addition, and it's also technology that we already have implemented. You can already delegate votes, but we would, I think, try to make it so that vote delegation is much more agile, meaning that you wouldn't have to manually undelegate before you're able to move funds, and you wouldn't necessarily have to pay anything to delegate. Secondly, and in addition, so building on this delegation to try to get people involved in the general referendum model would be to move beyond the adaptive quorum biasing and move beyond the fixed time with potential fast tracking model that we have now into a variable time limit mechanism with essentially allowing referenda to end early if they have a sufficiently high turnout and are sufficiently in favor or against. So essentially, for a referendum to end within an hour, there would have to be an exceptionally high turnout and exceptionally biased towards approve or reject within that turnout. But as time goes on, we would accept a lower turnout and a bit of a less of a bias one way to the other, in order to allow for the early ending of the referendum. And then the idea is that if it played through and had the entire 2 weeks or a month or however long it's meant to go for by default, and still hadn't sort of early exited, then it would exit without anything happening. So it would essentially fail.
Okay, yeah, that's interesting. Yeah, removing any individuals or more there's some really interesting plans for governance. Thank you. So this is an interesting question. It's kind of vague though. So I guess you can take it however you want. But what are some ways that individuals can help increase this decentralization and help promote Substrate and the technological adoption of the Polkadot ecosystem? What would you give as advice for people who want that?
Yeah, it's hard without knowing the specific skill set of any given individual. If they are, a great coder, then lending a hand either to the core technology within Substrate or to building great products on Substrate. If they're not maybe so much of a coder, but sort of a good networker, which meets a lot of people, do a lot of talking, then presenting on the key differences, evangelism, going to other developers and letting them know, right, well, this is why Substrate's a good idea, this is why Polkadot is different, I think is crucial. And generally, if they're non-technical, entirely non-technical, then just general evangelism of peer-to-peer and decentralization as a whole. So why is decentralization a good thing? Why is doing things in a peer-to-peer fashion a good thing? Why do we not want to have to trust authorities? Why do we, what's the problem with authorities? Talking about nexuses of power, talking about the potential for corruption, the potential for mistakes to have magnifying effects, the greater the centralization is. And this is stuff that isn't specifically to do with technology. This is just stuff, this is like, classic sociology almost. It's like why it's not such a great thing to place so much power into the hands of so few. I think if you Google for decentralization and social democracy and so on, you will probably find quite a lot of material on this.
All right. Well, thank you very much. That was a great speech and some great answers to questions. So we are out of time for this. So thank you once again. And
thank you, Bill.
And we will be back in just a few minutes. Welcome back. Next up, we have Rob Habermeyer, who is going to give a Parachains update, where we are and what's coming. Rob?
Hey, thanks, Bill. And I just got the end of Gav's talk. That was a good one as well. Yep, so I'm going to be going into Parachains, basically how we got where we are, what's going to be coming up next. For a little bit of context, I'm one of the co-founders of Polkadot. I've been working on Polkadot with Gav since 2016. And I'm also the lead developer and team lead of the Parachains codebase and implementation. So this is coming right from the horse's mouth. Well, first, let's dive into the the timeline, how we got here. We spent a lot of time sort of early on in the development cycle of Polkadot, just building, Substrate, building out those Babe and Grandpa consensus algorithms, building libp2p. So the development of Parachains actually was required a lot of those foundational components to be built ahead of time. So the first draft of the implementer's guide was in May. Apologies, my slides are incredibly blurry. But I'll just go through the timeline. The first draft of the implementer's guide was in May. What the implementer's guide is, actually have spoken about this a couple of times. It's basically a giant implementation document. What it is, it describes our motivations, how we think about writing a large piece of code like this, because when you dive into a large software development project, you really have to think about how are all of the pieces going to fit together. It's not something that can just emerge naturally of like, oh yeah, I feel like writing this today, I feel like writing that today. No, you have to, think about how that's all going to fall into place. So, if you're going to go somewhere like where we're going, launching Parachains, the implementer's guide, something like it, is incredibly crucial to make sure that that code is solid. This is a foundational infrastructure component. So that first draft of the implementer's guide was sort of May 2020, once it was in a state where we could really start building on it in earnest. And what it essentially did was divide the Parachains code into 4 major parts. So those are backing and availability, which sort of go together. validators finding blocks from collators and saying, hey, I think these are good, including those on chain, and then making sure that the data necessary to check them is there. The approval checking is the next thing. This is where really most of the security comes from. It's a way for, once Parachain blocks are on chain, that validators randomly self-select in a secure way to see if they should recover that data and then check the block themselves. And then finally, disputes is this escalation aspect. So disputes are if a validator detects that something is bad, then this needs to be escalated. It needs to reach all the other validators so that they can also participate and check it. Essentially, there's a very low, extremely low chance, right? We're talking about like 20 decimal points or something that an approval checking phase goes through without someone finding out that the block is bad, and that would be immediately escalated. So these things all kind of fit together to give us the security and the scalability of parachains. If you try to attack it, you're taking a 1 in 10 quadrillion chance that you're not going to lose millions of dollars. And that happens every single time you try to attack the system. So that's the code. Over the past couple of months, we've been employing SR Labs to do audits of the code, right? Checking the protocol, checking the implementation, trying to find bugs. And they've done an independent review. They've gone through various different components of Parachain's code base. Now, we use them for a bunch of other parts of the code as well, but specifically for Parachains, the audits were completed this fall. They raised a few issues, not many, and the fixes for those, as Gav mentioned in his previous talk, are around 50% done. And we have solutions in progress for the rest of those. So that gives us, this property of what we call technical readiness, which is after audits and significant deployments on Rococo and Kusama, Parachains are ready for an initial production release. Now, the caveat is we're going to fix those outstanding audit issues, and that's on schedule to be done before December. So the real-world deployments are also an incredibly important part of this. We have a Rococo test network, which I'll speak a bunch more about later, and that's it's a multi-region testnet that Parity runs all the nodes of. It has no economic value. It's literally just for trying out the technology, and we've seen how this behaves with hundreds of nodes, for instance. We've also seen a real-world deployment on Kusama. This is a totally different environment because you never know what's going to happen until it hits the real world. We can try to distribute it as much as possible on Rococo, but until it hits the real world, you don't know what's going to happen. And Kusama is an environment where you have 900 globally distributed validators. We have no idea who all of these people are. They're just running software on computers that they own or rent. And we've seen that on Kusama, it functions more or less correctly. So what does readiness mean versus maturity? And I have to apologize because my slides are also incredibly blurry. But what readiness means is that it works, but it isn't yet in its final form. The code is feature complete, right? It does everything that it's supposed to do. We've tested it, to a very high standard, various different edge cases. We've seen that has the correct properties. We do that for various different modules and also in the ways that we stitch together those modules. It's been audited. There have been independent reviews by security professionals who have a high regard within the space, and it's been deployed, right? We've demonstrated to function even in adversarial conditions. We come up with the different ways that someone might attack the system, and then we actually implement those attacks, and then we see if the system keeps working. And actually, if you go and look at the Rococo testnet right now, there are adversarial nodes trying to destroy the network as we speak. They have not been successful. But when something is ready, it might still have bugs. There might still be outstanding optimizations. You can never know for sure. And that's where maturity kind of comes into place. Once something has really evolved to the point where it's been a foundational, heavily loaded, highly reliable piece of infrastructure, over the course of several years, that's when something is mature. So there are a lot of optimizations that can be done something that's battle tested. For example, I take something like the Shanghai attacks on Ethereum, right? That was really battle testing Ethereum back in late 2016, where people were really going at it and trying to destroy the network. And when something is shown to withstand economic attacks in the real world, that's a huge step towards maturity. And the code is stable. It's maintained more so than it is developed. And that means that the innovation at that point is not happening as much on this level because its infrastructure and growth is occurring more at the fringes. So what is our road to maturity? What are some of the steps along that road? And I'm going to cover a few of the major ones, but not all of them. There's a lot of steps there. But a few of the I think really exciting things on the horizon are contextual execution, parathreads, and just general networking optimization. So I'm going to go into each of these three things, sort of break down what they mean. So if you've watched parachains functioning on Kusama or on the Rococo network, you'd see that blocks are being included once every 12 seconds. Now, this is not a protocol limitation, but it's rather an implementation limitation, right? So contextual execution is the road to 6-second block times. Additionally, within those 12-second blocks that we have currently on Rococo and Kusama, there's only a short amount of time where block execution is actually occurring. The idea with contextual execution is to ramp that up significantly. It's basically about preparing blocks well in advance and sort of building the parachains further off-chain, and then slowly, bringing those onto the main relay chain instead of building the parachain block right before it gets included onto the relay chain. So that means that you're sort of preparing well in advance. And this is an optimization we have mapped out. We have a design for it, and it's one of the priorities for the next year. Another one of the interesting things that's coming up is parathreads. So that's a dynamic scheduler of parachain slots on a block by block basis. Well, what does that mean? Well, currently a parachain is something that has, it has dedicated execution time. It's buying via an auction 6 months or 12 months or 24 months of dedicated, I get to make a block all the time whenever I want to usage of the system. And what a parathread is something for more of like a pay-as-you-go model, and it's very similar to a parachain. The code is really not particularly different. It actually only affects what we call the backing and collation phases. So there's other phases that I mentioned earlier of availability, approval checking, and disputes, totally the same for a parathread. And in fact, it's the same thing for contextual execution. So the availability, approval checking, and disputes code is not needed to change for any of this future feature set that we're trying to do. The networking optimizations are just a big, right? This is peer-to-peer networking. As Gav mentioned in the previous talk, peer-to-peer networking is a challenge. It's very difficult, right? Because in a client-server model, you have to, you get to just ping some server and it comes back very quickly. When you're doing peer-to-peer networking, the challenge of distributing data as efficiently as possible, that means quickly and also with low redundancy, but high guarantees of delivery, it's very difficult to do. So there are a lot of, I'd say, fairly low-hanging fruit with respect to networking optimizations that are going to just help out the performance of the implementation substantially. So I think these are some of the really interesting things to watch out for on the horizon of parachains. And coming up, I want to talk a bit about sort of this Rococo test. What does this mean for the community, and how can you guys get involved? So have done the clicker. Yes, reframing Rococo. The Rococo testnet, I'll go into a bit. It's been a testnet, as I mentioned before, that Parity is running all of the nodes for. And it's been primarily focused on internal testing, basically bleeding edge code that we're running. We're modifying very quickly, deploying adversarial nodes, things like that. But it does mean that, as we've found bugs in the development process, we've occasionally broken the chain. That makes it a very difficult environment for teams to deploy their own parachains on. And Substrate developers who are building parachains need to have a place to deploy and test cross-chain solutions. And I think, with XCM in the state that it is now, it's becoming more stable. It's something that people can really use. Those cross-chain innovation beds are going to be really important. So for that, we're introducing, what we're calling Rococo revamps. And the idea there is that, Parity will maintain backwards compatibility on the Rococo test network, ensuring that it doesn't restart or only rarely at pre-announced times, right? So when you register your parachain, you're not going to need to update your nodes or your runtimes, any more than you would have to for, say, something like Kusama or for something like Weston. That means that you can plan to use Rococo for a longer extended period of time and really use it as a place to cooperate with other teams. Another factor is automated parachain slots. So we've built a sort of scheduler of allocating time on Rococo to teams that register to use it. So they get, say, a week at a time. And these, week-long slots would be allocated to teams just automatically and fairly based on, availability. But we'd especially prioritize on Rococo teams that have deployed chains on live networks, because I think those are interesting. And we prioritize ones that are part of the Substrate Builders program, right? The ones that we're really helping with the technology and who have joined sort of our acceleration efforts there. And of course, this is a focus on community. We'd like to encourage cross-chain communication and experimentation on the Rococo network, right? Especially maybe at that higher level, not just of deploying parachains, but deploying things on top of parachains. I could see user interface or decentralized app developers that are leveraging multiple parachains really enjoying this testnet as well, that it's not just for the super hardcore, low-level builders. Yep. And I'll give a timeline on what that's going to look like. So today, I'm announcing our intention to revamp Rococo. We're going to follow that up with a longer form blog post that's coming soon. The technicals are being put in place. That means a new chain spec, reaching some of the parameters, things like, how long are the sessions, how often do the validators change, and things like that. We'd automate all of that, and then moving towards a launch of the final restart of Rococo that we would no longer use for internal testing. We're aiming for that at the end of November. And with that, I conclude my presentation. Thank you very much. Yes.
All right, thank you, Rob. That was really interesting. I'm really excited to see how Rococo evolves now. We had a few questions from the audience. First, has there been talk, or would you consider a battle testing event to community attacks on a test chain or even Kusama? Or is this something, these adversarial mechanisms you want to arise naturally or only with parity tests?
Well, I think the difficulty, right, is that somebody would have to be willing to risk quite a lot of real value-bearing tokens to carry out these attacks. We haven't observed it, or at the very least, if they have attempted, they have been unsuccessful. But the system is designed; it's a proof-of-stake system. It involves slashing, so it'd be very expensive. And I think at this stage, there are probably a few people who have both the technical skill and the financial backing to be willing to take on such a risk.
Okay. And I was wondering if you could talk a little bit more about some of the real world differences you've seen between Kusama and Rococo and West End and these test nets. You had mentioned like you see different things, right, when you're in the real world with so many validators across the world. Can you give us some ideas of what these differences are and what you've seen?
Yeah, I think absolutely. There are a few. The two key differences that I can think of are networking, basically. These nodes are often not deployed on uniform hardware. They're often highly differentiated from each other. The latencies at which they establish messages and connections and can send those across, and also how quickly they can process those messages. Just it's highly differentiated to I think a degree that we haven't reached on Rococo. And on the other side is just node versioning, right? Like Rococo might have a few different versions of nodes, but I think on the main network, especially with Substrate's forkless upgrades, you don't have that uniformity of versioning. A lot of validators don't upgrade their nodes that often, so they're running with slightly different versions of the consensus code, and I think this can also it would be a factor for emergent effects that you wouldn't see in a more clean room testing environment.
Are you trying to emulate some of these things, like different versions and artificial latency or something in the test nets, or are you just?
Yeah, what we've done is Rococo is deployed over several different regions, so globally. So this will have different latencies on the as well as having different nodes on some different versions, especially custom versions, especially ones that carry out attacks. Most of the stuff with respect to like checking custom delays and things has been done not on Rococo but in other environments, right? That we have some Docker image that we've used internally for like gating network messages for specified amount of times, or acting as though a node is on a very slow internet connection.
So on that note about these adversarial nodes on Rococo, can you say like what are some of the attacks or adversarial mechanisms they're doing? Are they like spamming the network? Are they giving bad messages, or a variety of things?
So primarily it's about the protocol itself. So we've got nodes that are reporting valid parachain blocks as invalid, and we want to see if this affects that gets detected. They're wasting everybody's time. They're escalating something to dispute, and they're getting reported and detected. The dispute is getting resolved. And on the other side of that, and this is the more important attack, we're checking that an attacker or a group of attackers who collude to include a bad parachain block are detected, right? They're detected by those approval checkers who then escalate it to disputes, and then those attackers get slashed and they're getting punished. But furthermore, that the relay chain then sort of reorganizes to avoid the bad parachain block. That actually affects the fork choice rule of the relay chain. So sort of building a chain in one direction and detect that there's something bad in this chain, and then you just sort of go backwards and everybody starts building a new chain. And, this has been running on this class of attacks has been running on Rococo for a couple of weeks now.
Okay. And one last question. So on this note of approval checking, can you explain how this is, like the current system is different from the original model with fishermen? Since I know those we've the idea we've sort of deprecated. Can you sort of explain quickly the difference between how those worked and what we're doing now?
Yeah, so the original design was looking a lot closer into fishermen, and the background there was that you have just user operated nodes, say even collators that are watching for bad stuff to be included. And if it is included, then they'd detect it, they'd submit a fraud proof, and basically earn a reward by doing that. So that had a number of issues. Basically, one, you need to delay finality for a fraud proof period. It means that you're going to have slower throughput, slower settlement, right? So that's kind of a design fallback of using Fisherman. And the other thing is, sort of the way the proof of stake works is that, like, because they're slashing, nobody attacks the network, so no slashing happens, right? And if you have something like Fisherman, right, as a defense mechanism, attack events are going to be, very rare, because it does work, right? It's not as fast as we'd like. But then you run into the situation where attacks are incredibly rare. When an attack occurs, the Fisherman nodes are all competing to get the payout, and only one of them will actually get that payout. There are a couple of maybe ways that you can improve on that, but not really substantially. We even thought of like introducing forced malicious behavior to do that. And essentially what that means, you could run into a situation where nobody is a fisherman, and that's not something you want to rely on for security. So we came up with a different system, which is based more on like random self-selection, just like incredibly low probabilities of an attacker being able to get away without somebody honest checking their block. And this means that we can have faster finality. We're not relying on fishermen to actually exist. The validators actually get rewarded for participating in this system. And furthermore, it can be augmented in the future. We actually plan to do this, is to augment it with a user-initiated dispute system.
Oh, okay. All right. Well, we actually have many more questions, but unfortunately we're out of time. So thank you very much, Rob. And it was great. And
Thanks, Bill.
we'll be back in just a few minutes. Welcome back. Next up, we have Pierre, who is going to introduce Substrate Connect. He'll talk about replacing RPC nodes with light clients. Pierre?
Hi, everyone. So, as Pierre just said, my name is Pierre Krieger. I'm a Rust core dev at Parity. Going to introduce you to some new cool tech, and my talk is titled Introducing Substrate Connect, Replacing RPC nodes with light clients. If you don't understand the title, don't worry about it. You will understand in a few minutes. This talk is about explaining a problem that all major blockchain ecosystems have, the substrate-based ecosystem, but also others, Parachains, relay chain, all together. This problem is that blockchain UIs are still centralized. I'm going to explain this problem and how we are going to solve it. So, blockchain, be it Substrate, Polkadot, or any other ecosystem, is a peer-to-peer network of nodes. So you can connect to the blockchain by starting a CLI application in the background. It connects to your nodes. These nodes talk to each other, exchange messages about blocks, transactions, grant payouts, and so on and so forth. But this node is just an application that provides no visual feedback about what is happening. If you want to actually know what is happening on a blockchain, you need a user interface. I need to plug this user interface to a certain node in order to see what's happening in blockchain, but also submit transactions. A user interface is, for instance, Polkadot Gifts or a fearless wallet or MetaMask, to take the example of Ethereum, and so on and so forth. And this communication between the node and the user interface uses what is called the JSON RPC protocol. Again, this is an industry standard. It's what we do with Substrate, but all ecosystems do that right now. But there is a small problem with that. Well, not a problem with that necessarily, but one thing to be really aware of is that this user interface is very dumb. All it does is show what the node knows. The node says, hey, there's this amount of token on an account, for instance, and the user interface displays it. It doesn't try to do anything smarter than just show visually what the node knows about the chain. So if you want to have a UI plug to a blockchain, you will basically have two possibilities. The first is to have the UI connect to your own node that you have started in the background. You install it yourself on your machine, you start the node, then you start the UI, and the UI talks to your node. The second solution is to use a node that is publicly accessible, that is hosted by someone else, by a third party. And these are the two options possible right now. The first one, having your own node, is way more secure because, as I just explained, the UI just displays what the node knows about the chain. If you're using a third-party hosted node, this node might be lying to you, or more simply, the node might be offline because they have a problem or something like that. But also, installing your own node on your machine is extremely inconvenient. You need to download it, you need to install it, you need to have it started in the background. It's very annoying for the end users who just want to use an application, whereas a third-party node is extremely convenient. And because it's extremely convenient, that's unfortunately what the vast majority of users are still doing nowadays. Again, in Substrate, but also in all other blockchain ecosystems, at least the ones I know of. And that's what I mean by blockchain UIs are still centralized, because you're actually connecting a UI to a centralized point of failure, which is a third-party accessible node. What we would like to happen is for users to switch to a third solution, which is to bundle a node directly with the UI, basically combine the UI and node together. So you start the UI, it's very convenient, just the UI itself, nothing more, and it's secure because the node comes with it. Sorry. But UIs nowadays are web pages, they are Electron applications, basically JavaScript. So in order to bundle a node with a UI, that means that technically speaking, the node itself has to be JavaScript, which is kind of complicated from a technical point of view. But that's what we did. So Substrate Connect is a real Substrate client that runs in JavaScript. So more specifically, it is a JavaScript library. You can find it on the URL that shows on the slide, npm.js. The package is called Substrate/Connect. And you initialize it. You can look on the right-hand side of the screen. You import a type named detector from this package. You use it like any other package on the NPM ecosystem. You create a detector. I will explain in a couple of minutes why it's called detector. Then you call detect.connect. Here we passed Westend, but you can also pass any chain spec. It's compatible with any Substrate-based chain, be it standalone chains, relay chains, Polkadot, Kusama, Westend, it all works. So this connect function takes 5 to 10 seconds, which is kind of long, but I'm going to explain afterwards. And after these 5 to 10 seconds, you have access to a Polkadot GS API. So what I mean by Polkadot GS API is the API type in the Polkadot GS library, which is also a JavaScript library. And then you can use it, as you can see on the example, like a regular Polkadot GS API. You call API.rpc.chain.get header, for instance. and you get the header of the best block, that kind of thing. And I want to emphasize that there's no trick. It's a node that is run in JavaScript. The node directly connects to a chain using the P2P protocol, which is the one we use in Substrate, uses WebSockets to do that, verifies all the blocks. And as far as we know, we're the first, at least amongst the major blockchain ecosystems, to actually do that, to actually have a light client in JavaScript. I said the word light client, but I'm going to explain that later, to have a node purely in JavaScript. Its API is extremely similar. So as I just mentioned, it provides you with a Polkadot JS API. So if you've already started writing a UI that uses the Polkadot JS library, you can very easily replace the connection to RPC nodes with Substrate Connect. It's a couple of lines of changes of codes to change, and boom, you're using Substrate Connect. Extremely easy. I must mention that the API that I showed at the previous slide is still going to change a little bit, but there's so little API that it should be very easy to upgrade. It's ready right now. Just go on npm.js.com, where you don't need to go on npm.js.com. You can just use the library like any other JavaScript library. But if you don't want to do that, you're not a dev or whatever, you can go on polkadotjs.org/apps. And on the menu, on the top left-hand corner of the screen on the Polkadot JS website, you can choose the chain. And when you select Polkadot Kusama West End, you can select Light Current Experimental. And if you choose this, it will use Substrate Connect. It doesn't work super great right now because we haven't upgraded to a lesser version. There's a couple of things to fix, but you can try it right now. However, there's a problem if we do that. Imagine a future where everything is blockchain, everything connects to a parachain. If you have 4 browser tabs open, each browser tab has a UI that uses Substrate Connect. Then you have 4 instances of Substrate Connect, which means 4 nodes, which means that each node connects individually to the various networks it wants to connect to. And that's kind of inefficient. In order to solve that, we are also developing a browser extension that is also called Substrate Connect. If you install it, then the various applications, the various browser tabs will detect that the extension is installed and will, instead of connecting directly to a blockchain, will talk to the browser extension, and the browser extension will then connect to the blockchains, which makes it possible to share resources between the various applications. So Substrate Connect is really 2 things. It's a JavaScript library, but it's also a browser extension. The JavaScript library tries to detect whether a browser extension is installed. If it is, then it makes use of it. If it is not, then it falls back to directly connecting to a blockchain. So if you just use the library, it's very transparent. You don't need to handle anything. It automatically detects whether the extension is installed at all. So a couple more details about the extension. It's providing a small UI. You know how browser extensions have small UIs. The Substrate Connect extension provides you with a UI showing the various applications that are connected to chains and which chains they are connected to. I want to emphasize again that the extension is optional. Users don't actually need to install it. If it's not installed, it's going to be less efficient. But Substrate Connect, the library, will automatically fall back to directly connecting to the chain itself. The extension considerably speeds up the chain initialization. So I mentioned earlier, it takes 5 to 10 seconds to connect to a chain. If you have the browser extension installed, these 5 to 10 seconds happen when the browser is started, and afterwards it's instantaneous because the browser extension is already connected. The extension is designed to be resilient to malicious web pages. So if you connect to a sketchy website, it cannot pollute the other applications that also use the same extension. And the extension is not completely ready yet. It's not available yet on the browser stores, the Firefox, Chrome store. I don't really know how it's called. You have to download the zip right now if you want to use it, but it's going to be ready soon. Next, how things work under the hood. So Substrate Connect does not use a full node, it uses a light client. When you compile Substrate or when you download Polkadot, the Polkadot client, you have what is called a full node. Substrate Connect instead uses a light client. What's the difference? A full node fully verifies all the blocks, whereas a light client only verifies the authenticity of blocks. What that means is light clients make sure that it's actually a validator which created a block, but does not verify whether each transaction is correct. It does not verify that because verifying this would require the client to hold the entire chain of the entire state of the chain, in its memory. And the huge strength of light client is they don't need any database. So nothing stored, you just start the client. It does not load anything. It starts fresh every single time. It takes 5 to 10 seconds to initialize from scratch, downloads the latest blocks and poof, it's ready. Whereas a full node needs a couple hours, I said on the side. It's no longer true because we're implementing more faster syncing technologies recently, but it can take a few hours or more than a few hours to sync the first time. A little bit of history. So if you've been following Parity, I've actually given 2 talks about this exact same topic in the past, but this time it's ready, whereas the previous talks were just like what we're going to work on in the future. We've actually started in 2018 trying to compile Substrate itself for the browser, for WebAssembly in the browser. But mid-2019, it was working, but really not great. And Substrate was really designed with some assumptions in mind, such as having a file system or having multiple threads, which are not really completely normal assumptions that you make. But for when you run a node in the browser, when you run a node in the browser, you don't have any file system, you only have a single thread. So it was kind of wonky. So what we did instead in end of 2019 is start a brand new Substrate compatible client named Sub0. And in 2021, Sub0 became ready enough to actually decide to ship it. So we started Substrate Connect on top of Sub0. And now we're shipping Substrate Connect, which is ready now. So I mentioned Sub0 in the previous slide. Sub0 is the name of the client itself. So it's an implementation detail of Substrate Connect. If you just want to use Substrate Connect, you don't need to know that, but I'm going to explain it anyway because it's interesting. It's written completely from scratch, that does not reuse any code from Substrate. It's written in Rust. And what we do, it's not actually a client in JavaScript. It's a client in WebAssembly, and the WebAssembly is executed by the JavaScript engine, either by the browser or by Node.js. It works, both Substrate Connect works in both the browser and Node.js. However, I'm going to add this talk with the main pitfall of Substrate Connect, which is connectivity. I mentioned earlier that Substrate Connect uses WebSockets to connect to the actual chain. But we have a major issue that we're dealing with, which is that web browsers do not allow web pages to open non-secure WebSocket connections. Meaning, if you have some JavaScript or WebAssembly that wants to connect to something through a WebSocket, this something has to provide a TLS certificate. Otherwise, browsers simply refuse this, which is a huge pain for us. Browsers design this with like Web 2 technology in mind. We are doing Web 3, which is better, but we still have to deal with this legacy problem. However, web browsers do allow browser extensions to open non-secure WebSocket connections. And maybe you see where I'm going with that, which is if the Substrate Connect extension is not installed, then Substrate Connect will only be able to connect to blockchain nodes that have a TLS certificate in front. If the extension is installed, then there is no such restriction, and Substrate Connect can connect to any node on the network. And for this reason, we would really encourage end users to install extensions, to install the extension. If you're a dev building on top of Substrate Connect, we encourage you to put a little message in a corner saying, please install the extension if you haven't, because perhaps more than the resource sharing problem that I explained earlier, this is probably the main reason why you are encouraged to install the extension, to not have any restriction on who you can connect to on the peer-to-peer network. But we also have a couple of improvements to this problem in mind. So instead of using WebSockets, we are also thinking of using WebRTC. It's kind of complicated, however, from a technological point of view. So it's something that we're going to do in the future, but it's clear not ready yet. The idea more precisely is to bundle WebRTC clients in Substrate itself, and browsers allow web pages to establish WebRTC connections to other WebRTC clients, meaning to any node on the network, assuming Substrate clients have a WebRTC client in them. Meaning no need for TLS certificate at all, even if you don't have the extension. Another connectivity issue that you're facing right now, if you're trying Substrate Connect, is that you might have issue finding nodes that have empty slots, because the nodes on a peer-to-peer network have a limited amount of slots for other nodes. A light client such as Substrate Connect uses less resources significantly than a full node, and in this regard we could allow more slots specifically for light clients, but this is not something implemented yet. But again, this is a future improvement. And the last idea we have in mind is to actually incentivize people to run full nodes, because light clients need to connect to full nodes in order to function. And in order to have enough slots for everyone, one idea is to actually pay people that are hosting full nodes in order for them to host the full nodes in question. And that's the end. So this was a high-level overview of Substrate Connect. If you're more interested in the technical details, we have a workshop tomorrow at 4 or 5. I don't remember exactly. I will invite you to look on the planning, and that's it for me.
All right, thanks, Pierre. That was really, really interesting, and I think this light client is going to be, a game changer that we can, decentralize quite a bit more because of it. So thanks. We have quite a few questions in the Q&A here. Someone wanted to know, what is your vision of how light this could get? Could you run it on a Raspberry Pi or a mobile phone? Is this something that would be possible in the future?
So that's an interesting question. Part of the core technology of Substrate uses a WebAssembly virtual machine. And for technical reasons, this needs at least 64 megabytes of memory, roughly. So you cannot run it on any device with less than around 64 megabytes of memory. But a Raspberry Pi definitely, a mobile phone definitely, there shouldn't be any problem with that. We're running Substrate Connect in the browser right now, and browsers being, well, not browsers, but WebAssembly being a 32-bit technology only has 4 gigabytes of memory. So if it works in the browser, we know it's not using more than 4 gigabytes of memory. 4 gigabytes is a lot, so don't use that as the actual number, but we know it's not using huge amounts of memory.
Okay, but I can't use it on my Commodore 64.
I've measured, actually, sorry. Just to say, I measured recently, it was using roughly 100 megabytes of memory at any time.
Oh, okay. So yeah, that's very reasonable, even for pretty modern lightweight hardware. Yeah. Okay. And someone asked, are there any security concerns with using a light client, either positive or negative, compared to just, connecting to a node?
To a JSON, to a RPC node, yes. So definitely, when you connect to an RPC node, when you connect a UI to an RPC node, the UI just displays what is in the RPC node's memory. So the RPC node could be lying to you. It could pretend that there is no money in a certain account. It could pretend you're on a completely different chain. It could show anything, basically. Whereas the light client actually verifies everything, well, not everything, but verifies the finality. It knows for sure that it's on the correct chain. It knows for sure that what it displays is accurate. It knows for sure that blocks have been offered by validators. And once the blocks are finalized, it knows for sure that the blocks are all 100% valid and correct.
Okay, yeah, so you don't have to trust that node since you are your own node, essentially, yes.
Yeah, definitely.
How would you interact with different parachains? Would you use the same client? Would you have to have different clients running? How would that work?
So we've designed Substrate Connect with that in mind from day one. Substrate Connect or Small.Dot, both Substrate Connect and Small.Dot can connect to multiple chains at the same time with one single client. So there's obviously a limit to the number of chains you can connect to. You cannot connect to 200 chains because there's only so much memory, what we just explained. But you can definitely connect to, I think the most I've done is 8 chains at the same time, and it was working smoothly. Basically, you're reusing the same client for every single chain.
Oh, okay. Oh, very, very cool. Someone wanted to know, is it possible to use the light client in Rust instead of JS? Is there a Rust version of it?
So this would require a couple of code modifications because the light client really assumes that it's within JavaScript. To be clear, the 95% of the code is platform agnostic, but the remaining 5% really assume that JavaScript is there, and we would need to make some modifications if you want to really use it in a standalone way, but it's definitely something feasible.
Okay. And has there been any talk about integrating the light client into already existing extensions like MetaMask or other extensions that are out there?
So you mean, for instance, the Polkadot extension? That's something that people ask me this question a lot. That's something that we have in mind, but no plan so far. So we'll see in the future. Yeah.
Okay. Are there any people that you or applications or reasons why you may suggest not to use the light client?
Good question. From an ideological perspective, I would say no. You use something decentralized all the time. Good question. I don't have anything in mind.
Okay.
Maybe there are, but not something I have in mind. Okay.
Could you compare this to a Bitcoin SPV client? Like, what are the differences between how those work and this?
I don't know what a Bitcoin SPV client is. I haven't followed anything Bitcoin for years now, technically speaking. Sorry about that.
No, it's yeah. So you talked about how having the extension bypass that the WebSocket restriction. Is that just because extensions by default are allowed to do that, or did you have to do something to hack around that to allow it?
No. Browsers allow extensions to establish non-secure WebSocket connections. We actually did not know that, and we were looking for solutions, and we randomly tried to establish a connection in an extension, and it worked. And so we decided to go for the extension solution. There is this kind of fear that browser vendors will change their mind and not allow non-secure WebSocket connections. Hopefully not. I'm not aware of any plan about that, but hopefully not. The 100% correct solution in the long term would would be WebRTC. But that's for the future.
Okay. Yeah. All right. Well, thank you, Pierre. As I said, that was this light client, I think, really is a game changer. Really appreciate having you on, and we will be right back in just a few minutes with the next presentation. Welcome back. For our next presentation, we have Tomasz discussing Substrate Bridges to Polkadot, the view today. Tomasz?
Hey, Bill. Thank you. Hello, everyone. My name is Tomasz Dobienga. I'm a core developer at Parity Technologies, leading the bridge efforts at Parity. So before I go into the main point of my presentation, describing bridges of Polkadot, let me kind of do a little bit of intro. What do we mean about bridges, or where we are in the stack here? So when we talk about Polkadot, Polkadot promises interoperability. It's basically all about interoperability. And what kind of interoperability do we mean? So first we have cross-chain communication. So having two parachains being able to speak to each other. If we zoom out, we may have cross-ecosystem communication. So we have two ecosystems, for instance, Polkadot and Kusama, both built with Substrate, communicating with each other through a bridge. If we zoom out even more, then we have something that we could call cross-consensus communication, where we connect to existing blockchains or other consensus systems that are already out there. So have you noticed this kind of common pattern on all of these slides? Interoperability is all about communication. And if we, it's all about like being able to speak to one another. And if we talk about communication and speaking, we need to think, what language do we speak to one another? And the answer is, our answer to this is XCM. So there is a really good series of blog posts by Gavin, and I really recommend all of you to take a look at this. And this is a quote from this blog post, which says, XCM aims to be a language communicating ideas between consensus systems. So looking at the stack here, we have XCM on the very top. So that's the language we are speaking. Then a little bit right below XCM, we have transport protocols that connect two chains to each other and make it possible to for them to speak to each other. And in this transport protocols, we have, for instance, XCMP. So this is like a direct connection between two parachains. We have vertical message passing, which means going through a relay chain. We have bridges as well, or we have custom relays. And what we connect is parachains, solo chains, and kind of entities living on parachains as well, for instance, smart contracts or L2 systems. So what we are going to talk about, and the way we think about bridges, is a transportation protocol for this language, which is XCM. So that's kind of to set the expectations for the rest of the talk. And essentially what bridge is, it's something that will tell the other chain, we call it a target chain, so the chain that we are trying to speak to, that some event or some message has been sent on the source chain. Okay, the target chain obviously will be interested, like, did this event really happen on the source chain? And the bridge can be implemented in various ways, and we have a whole spectrum of bridges here. So again, I'm kind of making a reference to wonderful resources that we have out there, and there is a really good article called Blockchain Bridges, which has this very nice classification and categorization of different bridges. And I'm kind of stealing the categorization from there on my slide here. So on the left-hand side, we have trustless bridges. In that case, the security of the bridge is as good as the security of the bridge networks. So we are not adding any additional kind of security related component there that usually just lowers the security of these networks, of this connection. And on the right-hand side, we have trustless bridges. So the security of the bridge pretty much relies on a reputation of the bridge operator. If we look at the spectrum in terms of kind of implementation complexity, I would say that these trusted bridges are relatively easy. Usually it's just a multisig on both of these networks. They are very much focused more on specific use case, and usually that use case is like transferring some assets, transferring tokens. But they are also very practical, right? So sometimes if the security is not that important for you, you can freely use that, because since they are easy to implement, they are available first. And then when we move to the left-hand side of the bridge, we have non-trivial implementation complexity, and also this very idealistic approach where the security is basically the highest it can be. So at Parity, we are mostly interested in the left-hand side of the spectrum. So we are interested in building trustless bridges, even if it's not that simple. So from the perspective of a trustless bridge, this proving to the target chain that some event happened is actually presenting a cryptographic proof that these events indeed did happen on the source chain. So how do we achieve that? How do we create this cryptographic proofs, and how do we make this trustless connection between these two networks? So I've given a bunch of bridge talks in the past as well, so I'm not going to go that much into details right now. I want to focus on the kind of second part of my presentation here. But basically, if we zoom in to this trustless bridge, we can identify 3 layers. Going from the bottom, we have the trust layer, which is an on-chain light client of the other consensus system. So we need to understand how the consensus progresses on the source chain in order to be able to construct these proofs and verify these proofs. On top of this trust layer, we are building this actual transportation layer or messaging layer. So that's something that enables us to queue messages and then receive messages on the other side. And on top of the messaging layer, we have the language. So for instance, XCM or something more specific to a particular chain that we are bridging to. These components that we are building are available for any chain that is being built with Substrate, or actually for any runtime that is being built with Frame. There is a link to our repository down there. Please feel free to take a look. And from the components that we have a bunch of components that in each layer that you can actually mix and match together. So in the trust layer, what we provide is a light client implementation of Grandpa in case the chain is a solo chain. We have a light client implementation of Grandpa for Parachains, which means, so in both of these clients, we don't care how the blocks are being produced. Either that can be Babe, that can be Aura, or it can be whatever else. We only care that the Grandpa finality gadget is there. So for the solo chain, the Grandpa finality gadget is running directly on the chain, which makes things a little bit easier. And in case of Parachain, the Grandpa or finality is achieved on the entire relay chain level, right? So we can follow Parachain finality by being able to verify finality of the relay chain. We have an Ethereum POA or Aura implementation as well available. This is being a little bit discontinued right now, but it's a proof of concept. This is something that we have started with, and it works. And if you have a case to bridge an Ethereum POA chain, feel free to try it out. And the thing that we are planning, and I will go a little bit more into details on my further slides, is Beefy and MMR. So in case of the messaging layer, we have something that is called message lanes implementation. So it's a transportation layer that allows, that enables order delivery, enables delivery confirmations, and also allows multiple lanes that kind of have these properties in parallel. So you can send two messages in two different lanes, and they will be delivered in parallel. However, messages within the same lane will be delivered exactly in the same order they were sent. Something that we plan for the future as well is a much simpler protocol without all of these features that we have in message lanes, but also with this nice property of being very cheap and very simple. And it's going to be an UDP-like protocol where you simply queue messages. They are delivered. They might be delivered in parallel. We don't really know the exact order, but also you don't get confirmations that they were delivered. So it's kind of send and forget. And in terms of the messaging, the language layer, the dispatch layer, currently we support a subset of XCM, which is substrate chain, encoded calls. So it's very kind of target chain specific messaging. And what we are planning to work on in the near future is XCM integration to kind of fill that block that I showed in the original diagram of having bridges as a transportation layer for XCM as a language. So yeah, now let me talk a little bit about bridges to Polkadot. And there is a huge asterisk there, because I'm going to talk about a very narrow subset of all of the bridges that are being planned for Polkadot. And these are going to be bridges that I was either personally involved in or my team was involved in. So I also encourage you to check out all of the other projects that are currently building for Polkadot. And the first thing that we've been working on for quite some time is a bridge between Polkadot and Kusama that would be running directly on the relay chains. The use case for that bridge is to allow on-chain entities to communicate and to basically prove that the bridge design that we have works. So the bridge will be quite restricted initially. Mainly, it's going to be used for, as I mentioned, this on-chain entities. As a consequence, for instance, Kusama Treasury will be able to hold and transfer the DOT token. And I'm going to talk about timeline on the next slide. So let me just focus on the next thing that we have planned. So a kind of natural consequence of this, or a next step for this, is when we have parachains on both Polkadot and Kusama, having a bridge running on the relay chain is not the most efficient solution. So what we would like to propose to both Polkadot and Kusama councils is to create a bridge that would be operating on the parachain level. So basically create a parachain for Kusama and a parachain for Polkadot and bridge these two. In this phase, we would be opening up the bridge for regular users and for other parachains to use it as well. We would like to enable XCM communication, so we would like to closely integrate with XCM. And in the future, we envision that this might be extended to include other bridges. This is this bridge hub idea that Gav mentioned on his keynote. Having XCM there would mean that any Kusama parachain could send an XCM message that would get routed to this bridge parachain, then routed across the bridge to the Polkadot side, and then from this bridge parachain on Polkadot routed further to another parachain in the Polkadot ecosystem. Obviously, the cost of sending an XCM message to another parachain or across the bridge is quite different. But having this connection available is sounds pretty exciting. So I've mentioned I want to talk more about this other trust layer component that we have planned. And this is Beefy and MMR. So initially, Beefy was designed to enable bridging with Ethereum mainnet. And I need to mention at least two entities and a few people here for kudos. So first, the Web3 Foundation folks who are working on the Beefy gadget, Alistair and Alfonso, and also the Snowfork team who is working on using that Beefy gadget to build a Ethereum bridge to Polkadot. The premise for Beefy is to allow cheaper verification of consensus because verifying grandpa is quite expensive if you want to do it on chain. We also want to have a much lighter payload to basically lower the amount of data that we need to send to kind of obtain this trust layer properties. And also a very good consequence of this is that we have unified data types. So while Substrate is extremely generic and allows every chain to customize their header format, for Beefy, the payload would be exactly the same, no matter what kind of header format the chains are using. So we would be able to speak to many chains without kind of adapting for them because they will use the unified data types. So what Beefy actually is. So this is an additional consensus round done by Grandpa validators. So it piggybacks on Grandpa. It allows crypto to be customized. So for Ethereum Bridge, we are actually using SecP 256K1, which is much faster to verify on Ethereum. In the future, we also plan to include threshold signatures. The proofs would be much more lightweight than Grandpa's finality proofs. And also the payload would be much more lightweight. So we don't even need to include header data. We can include something else. And the something else that we have in mind is actually MMR that I'm going to describe on the next slide, because Beefy together with MMR makes it very efficient to prove finalized and historical data at any point in time in the chain. And as I mentioned, Beefy is this consensus gadget. It's available now in Substrate repository. It's still experimental. We still need to do a bunch of tests before we can roll it out on any networks, but feel free to play around with it. And now Merkle Mountain Range. I've mentioned that this is a good companion for Beefy. So what Merkle Mountain Range actually is this kind of a Merkle tree with very efficient way of appending new data. So here on the image, you can see a Merkle tree with 8 leaves, which ends up having 14 nodes in total. And when we add a new leaf, if we would like to kind of create a Merkle tree out of this, we would need to add this artificial leaves to make a full binary tree here to compute the Merkle root, while Merkle Mountain Range is actually a forest of multiple Merkle trees that we still kind of compute a single root from the entire forest. So adding one more leaf here creates this kind of small Merkle tree, 15, 16, and 17. And these nodes 14 and 17 are called the peaks of a Merkle Mountain Range. And the peaks are kind of backed together to obtain a single root hash of the entire data structure. So MMR is actually a frame palette available in Substrate repository. You can enable that for your runtime. What it does, it computes a Merkle Mountain root hash in every block, and also exposes a custom RPC that allows you to verify and generate proofs for historical leaves. Leaf data is customizable. By default, it's going to be a parent root hash, but you can also put any kind of chain-specific data that you would like there. So combined with Beefy, we have this single hash of this entire structure of this MMR. And then without even looking at headers, we are able to prove that something that we are interested in actually happened in the chain, that this MMR structure actually contains some data in the leaf. Cool. So what are the plans here? So Polkadot and Kusama relay chain bridge is being audited right now. I think there is like 2 weeks of audit left. And very soon after the audit finishes and we fix all of the findings, we would like to propose this to be rolled out to networks. So we would like to propose this for Polkadot and Kusama councils. Next, we would like to focus on Beefy. So get Beefy on Rococo and get it into kind of production readiness. As a consequence, this will enable efficient bridging with Ethereum through the Snow bridge that I've mentioned earlier. And the next step, or something that we will actually do in parallel, is to move the bridge from the relay chain, or work on having the bridge running on the Parachain and having an XCM integration as well to enable this kind of nice use case of being able to speak exactly the same language independently from if you are speaking to another parachain within your relay chain, within your ecosystem, or outside of your ecosystem. And that would be all from me. I would like to invite you to our Element room, where you can ask us more about bridges, and also make sure to check the source code of the bridge palettes and also the components that are in the Substrate repository. Thank you.
All right. Thank you very much, Tomasz. That was a really interesting talk. We know bridges are extremely important in our ecosystem, and it's always really neat to see how they're being developed. We did have a few questions from the audience for you. So one, you had mentioned some limitations for the Polkadot to Kusama relay chain to relay chain bridge. And you mentioned as an example, just, holding, tokens for the treasury of the other chain. Can you go into a little more detail? What are these limitations? Is it just, entities on one chain can hold others? Is it certain extrinsics are handled? Like what are those limitations?
So from the bridge perspective, we could enable the bridge for basically, and we could open it up for any users. That would allow any Polkadot relay chain user or any Kusama relay chain user to be able to hold dots and make transfers on Polkadot. However, a long-term plan for the relay chains was always to have as little functionality as possible. So we don't want to kind of clog the relay chain with all of these bridge transfers. And also we don't want to inflate the state of the relay chain with all of these accounts that are coming from the bridge. So the limitation that we are introducing is kind of artificial, just to have the bridge running. So we kind of limit the entities that are allowed to use the bridge, so that when we migrate to the Parachain bridge, there is like less state to be migrated to this new paradigm that would be kind of more open by design, because it would be running on a Parachain. Is that a satisfying answer?
Yes. I mean, yeah, you basically put guardrails in, right? Is my understanding, like to limit the usage of it. It's not, but theoretically, it could be expanded outwards to do all sorts of other things. Okay.
Exactly.
So we had a question here, which I think it would be interesting to go into. Using XCM to interact with these other chains, do the other chains need to do any work to enable that? Is that something that we do entirely on our own? So for instance, when we have a bridge to some other chain X, we need to have chain X agree that, okay, yes, I will also implement this certain XCM capabilities, or is that something we can do entirely on this side?
So a full-fledged bridge XCM integration is still being worked on. So I don't have all of the answers here yet. But similarly to how you include an XCM in your parachain right now, you are also defining like how do you treat particular origins? What do you do with particular XCM calls? Which versions do you support? Like XCM is a language, but many chains can speak only like some dialects of this language. So they don't have to support everything. So similarly with bridges, like XCM has also this like two layers, I would say. One layer is the routing. So we know how to reach from one point to another and how the origin is translated between these different parachains. So the first goal of XCM and bridge integration is to include bridges in this routing system, where you can actually address a chain that is kind of behind this bridge. And the thing that will be supported, like I think the bridge itself will simply whitelist everything and will simply transport all of the calls if they are not to be dispatched on the bridge hub itself. If they are just like being routed and we just forward it to another parachain, we'll probably not even look at the content. Like don't hold me accountable for this. I haven't thought it through, but that's my at least initial impression, and we will be definitely aiming for that. And then the receiving parachain can see, oh, this is an XCM message that came through the bridge, so I might treat it differently, or I might do something else compared to what I would do if that was a parachain that is within my ecosystem. Because these ecosystems, even if bridged, they will have different security properties, right? So the security of these two networks are independent.
Yeah, so security actually is a good segue into the next question. Are there attacks that you're concerned about in terms of using this, the beefy bridge? Like, are there things that you're worried about, the other chain sending malicious messages or something, and how do you protect against those?
Oh, sure. There's plenty of possible attacks on pretty much like any layer. So we need to, like, when we are building this on-chain live client, we need to make sure that, for instance, whatever is presented to the on-chain light client is also visible or reported as equivocation. So a possible attack there is we have like validators doing a different thing on the network, but presenting a different thing to the bridge itself. So trying to fool the bridge. And then on the messaging layer, I would say like the kind of the most challenging part is making sure that the fees are covered for the relayers. Relayers are these entities that actually make sure that things that happen on one chain are delivered on the other chain. And we need to make sure that there is no kind of griefing attacks against them and they are not losing money by just like looking at the messages that are there. So yeah, and the weights, for instance, this is also a challenging thing. So yeah, plenty of stuff to think about.
Yeah, plenty of things to keep you busy. Yeah. All right. Well, thank you very much, Tomasz. We've run out of time for questions. So please just give us a few moments to prepare for the next speaker, and we'll see you soon. Welcome back. We have the first dual talk of the event today. So Andrea and Achim will be discussing browser-based smart contract UIs. So Andrea, please take it away.
Hi, thank you. My name is Andrea Eftene, and I'm a JavaScript developer at Parity. I'm part of the smart contracts team, and together with my colleagues, I build web applications for smart contract developers. The talk today will be about the current state of our new UI projects, which Achim and I will live demo here for you. I must add that this is just a sneak preview. The two projects we will demo today are not available yet to the public. We are planning to launch the two MVPs by the end of the year. But first, let's start with a bit of history. I'm going to do a quick recap of the core projects as an introduction for those who are new to smart contracts in Substrate and need to know what is available to them at the moment. Without going too much into detail, Ink allows you to write smart contracts in Rust, and Cargo Contract compiles them to WebAssembly, generating the metadata that is so useful for UIs. There have already been workshops about writing smart contracts in Ink, and I invite you to watch them if you haven't done so already. Moving on, the Substrate Contracts node, formerly known as Canvas, is made for developers for testing purposes. It's just a minimal Substrate node that includes the contracts palette, and you can run it locally to test your contracts. The contracts palette is what gives the Substrate runtime the ability to work with smart contracts. Some of you may have used the Substrate Contracts node via Canvas UI. Canvas UI was a web application where you could deploy your contracts on the Canvas testnet or local node. The metadata of the deployed contracts would then be saved in local storage, allowing the UI to generate the right inputs for your contract when you would later revisit the page. I'm using past tense on purpose because we have rewritten Canvas UI entirely and have some cool new features in store as well. This brings us to the present, where two new projects were born in the UI team. One is Substrate Contract Explorer, which will replace Canvas UI very soon, and Ink Playground, a special browser IDE for Rust-based smart contracts. Now, let's talk a bit about the Explorer and how it differs from Canvas UI. It builds upon the deployment and interaction features that were present in Canvas UI with the main goal of improving developer experience. We also want to create a developer community around Rust-based smart contracts where people can learn from each other, where anyone can easily inspect, modify, and redeploy contract code written by other members of the community. The new contracts UI will show useful statistics to the users, such as how many instances a contract has and so on. Users will be able to log in using a Substrate account and will be able to star their favorite contracts, similarly to how you would star a GitHub repo. By replacing a local storage with IPFS, the UI for your contracts will be available anywhere, and deployment of complex contracts will be much easier. We had a lot of feedback from Canvas UI users that error messages could be displayed in a more helpful way. So this is something we are looking to incorporate as well. In a nutshell, we want to create a complete web experience for smart contract developers. As I said before, that includes the ability to modify contract code in the browser. So I will now let my colleague Achim share his screen and tell you more about the Ink Playground.
Hi, my name is Achim Schneider, and I'm a smart contract tooling developer from Parity Technologies. So I have a background in React TypeScript and also in Rust and WebAssembly. And what I will talk about today, well, as we have learned earlier in the conference, like there will be an increasing demand also in tools for education and e-learning regarding Substrate and Parity and Polkadot. And so Ink Playground there comes in handy. Like just imagine that you go through some tutorial about Ink smart contracts, you're new to the topic and you just want to try out coding your own smart contract. And then currently this means that you have to install quite a heavy machinery of tools and like things like the Rust C compiler, like Cargo Contract, the latest nightly toolchain, probably some Visual Studio Code plugins, just to start experimenting a bit with the language. And even if you're an experienced developer, maybe you just want to try out some code snippet without creating a new project on your hard disk. And yeah, like what Ink Playground provides you is actually a browser-based IDE, meaning that you just have to enter a web address in your browser and it provides you with a fully integrated development environment. So this means you can start editing, writing, editing, compiling and sharing your smart contract code there. So a really nice feature that it includes is that it provides you actually with Rust Analyzer. So this means that Rust Analyzer is usually a plugin which you have installed working with Rust or Ink code on your local desktop IDE, and we managed to actually compile this tool to WebAssembly and execute it in the browser. So it provides you with features like syntax highlighting, auto-completion, go-to definitions, function signatures of functions you are trying to call or that you are calling from your smart contract code. So it's a really nice and cool feature, really useful for smart contract development in Ink. And it also allows you to load all the Ink smart contract source code so that you really see like what functions you are calling, what parameters are required, what's the return value. So yeah, then next, when you're editing smart contracts in the browser and you would just like to check if those smart contracts compile, or you would actually want to compile and download them to deploy them with Contracts Explorer, yeah, you can do this. So it provides you with a one-click compilation functionality of smart contracts to WebAssembly. And then last but not least, it also allows you to share the code you're editing. So there's a button which allows you to create a GitHub Gist, and then it provides you with a link to this GitHub Gist, so that just in the case you are stuck with a bug while editing your smart contract and you would like to discuss with other people, then you can create a GitHub Gist with one click, and you can share the link to this Gist in a forum or with a colleague, or you actually it also provides you with a second link to the Ink Playground itself, which encodes the ID of this GitHub Gist. So if you share this link with someone, then this other person will be provided with a Ink Playground IDE, and it actually, opening this link, it already automatically fetches the GitHub Gist content for you and provides you with the content of the smart contract code you were editing. Okay, this is actually a small screenshot of like how the Ink Playground currently looks like. And you see it's currently separate from Contract Explorer, but you can imagine that this becomes like a really, really useful tool in the future when you, that at one point in the near future, you will probably be able to write your smart contracts in the browser. Then you can compile them, you can deploy them on some chain or your local node, and then something doesn't behave the way you expect it to be. And then you can just jump back to the source code, modify a few things, recompile it, redeploy it, and it's just one workflow of smart contract development. So that's what we aim to accomplish. Okay, so let's just jump into some live demo and see how we can actually currently edit smart contract code with Ink Playground. Okay. So I open the website, the web address, and you see it loads the playground, and it provides you with a code editor. It takes a few more seconds to provide the Rust analyzer, but it's something that you're also pretty used to when, in case you ever use the Rust analyzer in Visual Studio Code, it just takes a few seconds to load all the project dependencies into its database. Oh yeah, and that's already available. And then you see that I can just navigate through the source code and that I can hover over some things, and it provides me with a with the function definitions, and it allows me to actually I can jump to function definitions. It provides me with the required parameters. It complains about syntax errors. And actually that's like a pretty cool and useful feature. So, and then let's assume that there is some typo somewhere in the code. Oh, actually that's a typo which gets already like marked. So, and I try to compile, and you will see that it won't compile. So there's some much more complicated error, which currently like the Rust analyzer itself at this stage doesn't reveal, but then trying to compile it throws an error, and it provides you with a backtrace, and you will be able to fix the error. And then, it will actually compile, and you will be able to download the contract bundle And then the last thing I was talking about was that it also provides you with some sharing functionality. So let's see how this works. I can create a GitHub Gist, and then I can either open this Gist, and you see that it actually created a new GitHub Gist containing the source code. And yeah, actually the source code that you see here, what this is, it's just the standard ERC20 token. It's the source code defining ERC20 token, so a quite standard smart contract example. And here's the second link I was talking about before, and this is actually the link which allows to open the playground and load the content that I was currently editing. And what I will do now is I will copy this link and I will share it with my colleague Andrea. Actually, I can also click this button. And Andrea will open the link and will just one-click compile this ERC20 contract and then download it and deploy it to Contract Explorer. So Andrea, here comes the link.
Thank you, Achim. Just a second. I have a few screens here. Oops. Sorry. There we are. So I have opened the Explorer and now I will compile the contract. Yeah, this usually takes a few seconds even on my host, but it seems like it's much faster here. I have downloaded the contract and now I'm moving to the Contract Explorer where I need to upload the new contract code because we just compiled it. Here I'm presented with the instantiation form in 3 steps. I can input my contract here, give it a name. Here on the next step, we can choose the deployment constructor, but in this case, we have only one. I can pass a value here. The instantiation options are pre-filled with the default values, and I'm not going to change that at the moment. On the last step, we can review our inputs and instantiate. So the instantiation is complete now, and I have been redirected to the contract page where I can inspect the metadata, where I see useful information about the methods that are available on this contract. And I also can, for example, check the balance of the contract owner or even transfer some funds to Bob. This usually takes a few seconds. A few more. All right, looks like the transfer succeeded. I can now check the balance of Alice again and see that the amount was subtracted from Alice's balance. One last thing I want to show you is how quick it is to reinstantiate a contract. You see the UI has been populated with the on-chain code hash, and I just can click, instantiate. All right, so that completes our sneak preview live demo. I will now move back to the slides where we can talk a bit about future plans. So as I mentioned earlier, the two new projects will be launched very soon in an MVP phase. What does that mean exactly? For the Contract Explorer, it means a tool for local development that has all the previous features of Canvas UI. In the MVP phase, it will only work with Substrate Contracts node or any other local node that has the contracts palette. For the in playground, it means that it will be a standalone app at first, moving towards a full integration with the Explorer. The Contract Explorer will get the ability to deploy on any chain soon after the MVP is launched. And sometime in the second half of next year, we expect to complete all the milestones, including the IPFS community and the integration with the playground. Okay, that was all for today. Thank you so much for watching. I forgot to add a thank you note slide.
Okay, thank you very much, Andrea and Akam. That was very very interesting talk. We had a couple of questions come in from the QA. I think first, just would you have any recommendations for people who are interested in learning about Ink, about like starting on it, that they could then use your tools?
Yeah, sure. So we already have a few tutorials available, and also the previous editions of Sub0 had some workshops that I think are very interesting for newcomers. And as I said, in 1 month we will launch these two new tools that and also provide some new tutorials for people to learn.
Okay, great. And I heard you mention at the end that like there's sort of a second step coming where you'll be able to deploy to different chains and different parachains. Are there any difficulties in deploying from one chain, providing support from one chain to another, or is this just pretty straightforward?
It's one of those things that looks straightforward but isn't. So yeah, we expect it to be done very soon after the MVP. So it's not where the greatest complexity lies.
Okay. We actually had several questions about VS Code. So okay. One, yeah. So are there any plans to make an extension directly from VS Code? Like take this? Is that something that's possible to do? We're not.
I think Achim is more.
I mean, it's currently not on our focus, and I would say that like Rust Analyzer is a pretty good tool which is available for Visual Studio Code and which allows you to provide you with quite some nice tools, which are of course developed generally for Rust. But our focus was currently more bringing this into a browser-based IDE because in the end, like Ink contract code it's actually Rust code together with some extra macros. So I'm not aware of any plans of any current ongoing activity for a specified Visual Studio Code plugin, but yeah, see.
Okay. So how do you mitigate against like malicious like code injection attacks? Like, is there something that people could try to put in some sort of smart contract code that actually would interfere with the IDE running? Like, do you sandbox it somehow?
Yeah, actually, we sandbox the compiler, but our main first target for those tools are actually to provide a tooling for learning and tutorials, and then we like regarding the playground, the compilation is handled in a sandbox, and it's secured, but yeah.
Okay. So we had someone ask, what is your opinion on Ask, which is the assembly script sort of variant of Ink, and if you had any plans to work with that as well, or feature that, integrate that into the code?
So yeah, the Substrate Contract Explorer is meant to work with any kind of smart contract that compiles to WebAssembly, so it's not necessarily linked to Ink. this is definitely something we want to do in the future.
Okay. So I think those are all the questions that we have. We're a little bit early, but thank you very much, Andrea and Achim. We really appreciated you showing this to us and going through everything and answering all of our questions. So,
thank you.
Thank you.
Thanks.
So we're now going to go into a bit of a break. You can use this time for networking or just enjoy the music. And after the break, we'll return with Bjorn, who will be discussing the Substrate ecosystem, the big picture. Hi, welcome back, everyone. I hope you enjoyed the music and/or networking. We are back with our next talk of the event, which is Bjorn talking about the Substrate ecosystem, the big picture. So please take it away, Bjorn.
Hey, everyone. Today, I'm delighted to give you a short update on what we've seen the Substrate ecosystem evolve into over the last year, really. For that, I'll be looking at our ecosystem from 4 different angles. Let's start with technology. Now, as you all know, right, there are many bits and pieces that need to fall into place for a blockchain framework to be particularly useful. In the case of Substrate, it all started with its eponymous client node code base, which has been our Parity's flagship offering for creating nodes to be run on server and desktop. Now, if you followed the previous talks of today, you will have heard that we've just released 2 more clients that I'm really excited about. Small.dot being one, which is an ultra lightweight client designed for resource-constrained environments, such as mobile and embedded systems, as well as Substrate Connect, which now lets you and your chain's users run basically any Substrate-based chain right from within their browser. But we haven't been the only ones that were hard at work. Other community members haven't stood still either. So on the client libraries front, for example, we've seen the rise of APIs for basically every major programming language. Most of them built and maintained by other companies than Parity. And it really doesn't end at just client libraries, right? There's a multitude of other tools that make Substrate a compelling home for Web3 builders. To name a few, I listed here a few for you guys that I think are definitely worth checking out if you haven't used them yet. One being Sidecar, which has had dozens of businesses by providing an easy way to interact with Substrate nodes via REST service. Then we have Subquery, which really enables everyone to process and query their chain data. And last but not least, as our tools built by Schefter, which really lets you build your Substrate WASM runtime in a deterministic way. Now, overall, we've seen the amount of APIs, tools, and services, such as those that I was just speaking about, that are readily available more than triple over the past 12 months. In total, we are looking at more than 80 products being available to make Substrate builders more productive today. But really, looking at the data, I believe that's really just the beginning. As, for example, we're tracking another, I believe, 83 products and services currently being developed by and for the Substrate community. Now, I brought you a little map here to emphasize how diverse the categories are in which tools are being built today, right? As we talked about client libraries, we have those. We have a multitude of really good block explorers by now. The dev tooling is really coming together, other sort of dev tooling. On the smart contract side, we have a couple of VMs now. We have at least 3 smart contract languages that can target Substrate-based chains. And even on the services side, we've worked pretty heavily with different auditors in our space and facilitated work with our community projects to really get them up to speed and have them be a very significant resource for security audits and reviews. Now, let's go over to the runtime engineering side of things, the chain's business logic, right? There we see a similar picture of tremendous growth of available modules. Today, more than 300 frame platelets have been published. Now, hearing about these quite significant numbers, both on the component side and frame palette side, you may ask, how do I find them, right? And rest assured, our team has been working also on that pretty hard, and specifically on creating a product for making it orders of magnitude easier to discover palettes and all these other platform tools mentioned. And I'm very optimistic that we'll be able to share our work with the community in the not too distant future. So next, I want to share with you a little bit more about the human side of things, like in the ways the community has come together. Now, over the past 1.5 years, our community has come together over 500 times. And surprisingly, a good part, if not even the majority of these gatherings, have been in-person meetups. Again, organized predominantly by other community members in Parity. And you know, if you look at the geographic distribution, you will really see that those gatherings have taken place all across the world. And I'm really happy to see that. On one hand, we see the usual suspects, such as Berlin, in terms of locations, as well as new local communities forming, such as in Belgrade, where we recently had the first meetup recently took place, as well as in Chengdu, China, which all have been part of those efforts. I think overall, it's really fair to say that our community is flourishing across online, in meet space, and as well on social media. Now, for example, on GitHub, right, we see hundreds of unique contributors across alone the core Substrate repositories. So let's speak about clients and some of these libraries that plug into our client. But beyond that, and you know, that's something that even excites me more, right, is that we see thousands of ecosystem repos. And beyond that, again, right, we see our Substrate technical chat room or metric today boasts, I believe, 6,000 active users. And the Substrate Discord gathers an incredible 13,000 participants today. Last but not least, you know, you all are aware that there are significant overlaps between the Polkadot community and the Substrate community, as well as with the Kusama community. And on the Polkadot side, they exist in the Messenger program, which today has over 1,700 members and is thereby one of the largest community programs of such kind. And Twitter, you know, is going really well as well. So I welcome you to follow and join the program, ambassador program, if you're interested to contribute and maybe start your own local community in a place where you are, if you don't have one. Now, next I want to talk chains, right? That's the sort of things that we're all here to build at the end of the day, right? Or that we are set to enable other people to build. We at Parity are really, really, really excited that we can follow more than 150 teams building a blockchain with Substrate today. And again, I brought a little map for you today to get a sense of which sub-ecosystems are particularly flourishing, or as other ecosystems, sub-ecosystems really could use a couple of healthy competitors. And I believe as one would expect, right? There are a multitude of amazing projects, particularly pushing the boundaries in DeFi as well as the NFT gaming space. But we are also seeing many blockchains that seek to provide compelling functionality to application developers, and even other blockchains, such as in the multi-chain context of Polkadot today. Like, well, I'm thinking here, the identity projects, right? The distributed file storage projects, right? As well as some others that you see here. Bridge projects, for example, right? Let's go on. As of today, 26 Substrate-based projects have launched a production network. That's super impressive, given the amount of time this framework has existed. Overall, we see that there are at the very, very least, more than 10,000 Substrate-based nodes running today. And honestly, I expect the hidden figure here to be much, much higher, as our telemetry service caps the number of nodes that we track per network at roughly 500. The 26 production networks that I mentioned, right, both together a mind-boggling combined market cap of around $50 billion today. And, you know, from here, I really want to go into opportunities, right? Opportunities that our ecosystem presents to those that might be new to it. So let's cut to the chase for those of you that want to get more involved with Substrate and its community. So I believe, let's start with individuals, right? For those developers of you that haven't, aren't part of a larger team yet, that haven't started a company yet. I think no matter if you're just getting started, right? Or you're even having been hacking with Substrate all along, right? I highly, highly recommend you checking out our brand new and just launched Substrate website under substrate.io, where besides other things, you will find much learning materials for really all levels of all skill levels. Now, let's go from here, right? Let's think. I guess if you don't want to, you know, if you want to get started, but you don't want to walk alone, right? Learning alone. One way to get started is join hundreds of other students that have taken part in the readily available Substrate courses, right? I believe to date there have been roughly 13 or 14 cohorts that have been facilitated by these different course providers. An alternative is you really show up at the Substrate seminar, which is our version of a free collaborative online learning. Now, if you don't want any teaching and instead get your hands dirty right away, you know, for the hackers out there, check out some of our tutorials, again, to be found on Substrate.io, or join one of the upcoming Substrate or Polkadot hackathons. Some of our team members have been really hard at work here, putting together a new global series that will reach all developers in all regions. Now, I believe, if I'm correct, we start with the APAC region, and that should be, if it hasn't been announced already, it should be announced very soon. And, you know, with these hackathons, you might actually, besides having a great learning experience, I think you might even end up starting your very own project right after. Now, if you're more the type that is keen to team up with today's Substrate experts, right, to join a team that already has a tremendous amount of knowledge internally, right, please come forward and join Parity, our company, the Web3 Foundation, or one of the very dozens of other companies that are hiring now, right now. I can highly recommend there to check out .jobs.nest, which when I checked earlier today, I listed over 192 open positions. And, you know, I think together that really shows these Substrate skills are in very high demand today. So let's see where we go from here. Right. Are you ready to start your own project? Or maybe have you started your own project already? Well, I think that would be fantastic and is fantastic, and our community is here to help. Again, no matter if you as a team, right, are very small and you're just getting started, or you're already a sizable teams, we've come to a place where there really are funding opportunities for everyone, right? So on one hand, right, if we look at venture funding, we see that today over 50 major VC firms are actively looking to invest in Substrate-based projects. And I think more than 100 million has been deployed today. Beyond that, we've seen a bunch of incubators and accelerators in recent months really have become very active in our ecosystem, and we know of some more following suit in the coming month. Now, for example, and as an example here, right, like a interesting tidbit, I believe more than half of the UC Berkeley's last accelerator cohort was building with Substrate. Now, if you're not really looking for venture funding, right, and are much more interested in grants for building open source technologies, again, regardless if you're, you know, a sole warrior keyboard warrior or if you are a well-functioning team, right, I highly recommend you to check out the Web3 Foundation Grants Program, as well as what's been happening on the Polkadot and Kusama on-chain treasuries. Looking at the Web3 Foundation Grants project, right, to give you some numbers here, right, those, for instance, have awarded over 300 proposals with a total of over $100 million to date. And I think even more excitingly for me, the Polkadot and Kusama on-chain treasuries, right, in a decentralized fashion, has heavily increased their activity and has by now funded over 140 proposals with tokens worth over $30 million at today's value. Last but not least, I would like to encourage you to check out what our team at Parity has to offer for you in terms of technical support. And I think there are two good ways for you to do that. Number one, and that's a better one, stay on the line, enjoy my my colleague Ben's talk. I think that's taking place right after mine here. Or alternatively, go on Substrate.io on the community section. There's an opportunity section where you can read about many of these things and figure out how you can get the support that I presented you. And that's about it. Thank you very much, guys. And I'm available for any questions now.
All right. Thank you very much, Bjorn. We certainly have a few questions here. But before we start, I just want to remind people that if you are interested in joining the ecosystem, we do have a jobs chat board right now happening on Discord. So please feel free to go over there. Or if you are looking for someone for your project to work with you, that job board is also a good place for you to post your own job descriptions. So one question that came up is, do you have any recommendations for people that are non-technical to get involved in the Substrate ecosystem?
100%. I think, like, generally the Substrate ecosystem is a rather technical one, because it is in itself a developer tool that you can use for all sorts of technical stuff, right? And it certainly is a powerful tool to build your Web3 business on top of it. Yet, what I've seen might be a better starting point is the Polkadot and Kusama communities online, right? I believe in their chat channels and even in the meetups, right? Check out the Polkadot ambassador programs. That is really, they also have events where also non-technical people really come together. Now, on the other hand, I believe, Bill, you might have a course that might be interesting for one or the other that isn't as deeply technical. Is that right?
Yes. So if you are interested in learning blockchain from the fundamentals, you can learn through my MOOC, Blockchain Fundamentals, which you can find on the Polkadot channel. Thank you for giving me an opportunity to shill my course, Bjorn. Appreciate it.
For sure. Beyond that, there are a couple of other things that come to my mind, right? So generally, I think the best thing is go out there, talk to people, be it online or go to in-person events and just socialize and share your ideas and brush up on your knowledge, right? That's one. The other one is really there are a number of incubators, right, that will help you, will facilitate teaming you up with technical folks, right? And sometimes that's really just what you need, right? And I think we certainly should think ourselves about making that a lot easier, right? Maybe starting a forum, maybe starting a matchmaking platform where we bring people together in order to facilitate that. And last but not least, on the hackathon side of things, I would say that's a great starting point too. Because what people often forget is that at hackathons, you need folks, for example, that understand design, right? That don't just code, understand design. You need folks that understand their industries very well. So if you're an industry expert, I've seen hackathons where people would have killed to have somebody that really understands supply chains or some other industry to actually validate their ideas and make sense of their products. right? So like, don't take it too much as a hurdle, you not knowing yourself the ins and outs of Substrate, and really just make sure you go out there and give it a try.
Yeah, I think that's great advice. Not just for this, but for life, right? To go out there and give it a try.
Yeah.
Do you have some ideas of particular areas or types of tools that would be valuable for the ecosystem that would be ideas for people to work on?
Yes, I do, and I can also point you to a few points. Few places where you can stay in the loop now. So one resource that I would like to point out particularly is the Web3 Foundation grants GitHub, because they actually have RFPs open on one hand and give you a good sense of what is needed and asked for by other communities members. Now, like if I, my kind of moonshot try here, right? Just shouting it out. If you're one of the 24, right now, that could build a ZK parachain, right? That could do that, then I think you will have plenty of opportunity to get all the support in the world to make that a successful endeavor. But really, in all these areas that I pointed out earlier, right? Like be it on more the benchmarking testing side of things, right? Like making it much easier to, for example, determine your weights that your runtime should assign to certain functions, right? That's an incredibly useful tool. If you go more in the security analysis, right? Statistical analysis side of things, right? Super helpful. On the IDE side of things, right? Like we do have some plugins here and there for IDEs that make it easier to build runtimes, right? That gives you all the builds and risks to get your productivity up. But I believe there's still a lot of room to build better products and better services. I honestly, I think the opportunities are pretty endless here, right? Yeah. And even if you go out there and see, what's already available, and I'm sure we will publish my slides somewhere, right? And you take that as a starting point, play around with some things. There will be obvious ideas that come to your mind, how you can potentially even combine certain of these things to create very compelling tools and offerings and products.
Yeah. Thank you very much. That's a great answer and covers a lot. So actually, you had brought up supply chain in your answer, and this brings me to another question that somebody had asked, which are there enterprise projects right now on running on Polkadot, or people developing on Substrate, or is this mostly like new teams, greenfield development, or are there enterprise projects applying this to current large industry?
There is so interesting enough, there is a range of enterprise projects, even though historically we as Parity at least haven't focused on catering to enterprises, right? Over the years, right, we have ramped up our efforts there, right, to also present enterprise with a compelling offering so that they can use this very, I think, tremendously interesting tool for enterprises to pick it up. And I want to give you a couple of examples. So I'm aware of, actually, are my slides still there? Because you can actually see a couple of these. Now, I'm going to wrap it up quickly. So we have transparent systems. Amazing folks, right, that build a money market system, payment system, B2B payment system, and straight up focus on banks as their clients. Actually, you might be aware, it was shared with me that a bank called Northern Trust runs Substrate nodes, right? We have a number of other clients, German government agencies such as the German Agency for Energy is building a Substrate-based chain. We have MediLedger from Chronicled building with Substrate for the pharmaceutical supply chain industry. And there are a bunch of more that I might have missed. Now, one thing I want to say, if you're interested in that, make sure to reach out to us. We do have an enterprise team that have ramped up their efforts quite tremendously over the last 6 months, and they would be more than happy to speak to you and like connect you with relevant parties as it might be interesting to you.
Yeah. All right. Well, thank you very much, Bjorn. We are out of time. I appreciate answering all of the questions and, of course, for the presentation. So please wait with us for just a few moments while we prepare the next speaker. Welcome back. For our next talk, we have Ben Weiss, who is going to be talking about the Substrate Builders Program, where ideas become blockchains. Ben?
Yeah, thank you, Bill. Thank you very much for everybody being around. I'm Ben from the Ecosystem Success team at Parity, and I want to walk you through the Builders Program today, and what it is about, what the current status is, and what to expect going forward. So let's start out. What is the Builders project actually about? The Builders project initially got established with the goal of empowering external high leverage development teams to build out the best in place blockchains in the space. And surely it was a focus on Substrate and being successful in the Polkadot ecosystem. And that's the whole goal of the Substrate Builders program. So looking back on how the Builders program actually got established. So it got launched, or the initial launch happened in December 2019 with an initial track we separate teams in different tracks as they need different support initiatives, but it started us with a chains track. The chains track really focusing on teams building chains, parachains, solo chains, any chain based on Substrate. And we're aiming giving them the right support, the technical support for sure, from Parity side to be successful. We shortly got aware that there is something more needed. And this was the establishment of the infrastructure track. The infrastructure track then aimed for teams, or is aiming for teams who are building infrastructure tooling in the context of Substrate, like making it easier to develop a chain with Substrate, deploying the chain, maintaining it going forward, and giving access to that Substrate chain. And after the first chains got built and the first parachains came available, we established the application track. The application track is a support initiative that aims for teams aiming to deploy on a parachain. But with the establishment of the parachains and their own communities, we figured out that we need something more. And something more was literally the establishment of the Builders for Builders program. The Builders for Builders program is a way that we help parachain teams establish their own community and share our knowledge that we gathered through running the Builders program, like back at the time, for over a year, and help them to help their teams getting deployed on their Parachain. And this was like October 2020. But then beginning of this year, mid this year, we saw with like the Parachains actually coming to life and getting ready to connect to the relay chain, that we need something like a launch support. And the launch support is aiming to help teams to get this knowledge that Parity has created while launching a couple of chains, and making sure the teams actually know how to do, say, DevOps right, how to ensure that these parachains are actually available, that they're running, that they're well prepared, that they are launching in a successful way. So now going into the Builders program itself, what is actually part of the Builders program? So the Builders program is established in 4 different phases. So it's the evaluation phase, it's a building phase, it's a launch support, and the long-term coordination support. If we look at these phases in themselves, they're actually established in different pathways. So we have the application in the first step. That's literally the application where a team goes into and fills out the form, gives us some information about their project. And there's one minimal requirement. It's a POC MVP level, so proof of concept, minimal viable product level. So a team needs to have built something and in the vision of their project. And then we invite them into an intro call. We get more knowledge about their project, and we estimate if it is like worth to go into the pitch call. And the pitch call is the last call for a team in the application phase. This is when a team actually has the chance to convince us to give us all the support. And there's a Substrate Builders program committee that is composed of people from the Web3 Foundation and from Parity, who would then evaluate the team and ensure that the team is valuable to give all the support that we are actually deploying on that team on the Builders program. So if we're looking then, if a team gets accepted and the team goes into the building phase, it's really about hacking and building. So hacking and building in the sense of different milestones, which have a different focus. So the milestones are separated in 3 different milestones, which are over 9 months and lasting for 3 months every milestone. And the first milestone is then building up on the POC and MVP on their initial build and their initial idea, and making sure they establish a proper roadmap, a technical roadmap, to be able to execute on their ideas. And all of these, like in the building phase, all of the building phase, we have different support initiatives. So we have for sure technical support, we have marketing and communication support, business support. So we say like, is the business a viable product? Does it actually make sense? And this is always like, all these initiatives or these support initiatives are available for anybody in the ecosystem on a demand basis. But in the Builders program, we package them together so we can apply them in a very structured way. And then if we're looking at the milestone 2, it's really about building out the first features, building these idea and building this roadmap out, and ensuring that is like lined out on a good way to build the product. And the last milestone, milestone 3, is getting ready to connect as a parachain. So connecting as a parachain means literally testing everything, ensuring the parachain is production ready, it's possible to connect. And with the milestone 3 getting reached by teams, we are entering the launch support. And launch support is then going into connecting as a parachain testnet, making sure that runtime upgrades have happened and tested before, and have like security reviews lined out and code audits sort of scheduled. So when it comes to a team wanting to connect as a parachain, going to Kusama, going to Polkadot, it's really to ensure that the code is like audited, that there is like security reviews, and ensuring the best practices in the ecosystem to have like a mature as possible project. If we're looking at the stats in the Builders program, so generally, since we are running the program almost for 2 years now, we have had like over 320 applications so far. And we were able to accept around 56, 58 teams in the Builders program. And with these teams looking at the different tracks, we have around 48 teams connected, building a chain, building a substrate-based chains, around 10 teams building an infrastructure product, and around 4 teams building a dApp, like an application that is aiming to get deployed on a Parachain. The 4 teams is a little bit low on the application side, but it makes sure, because like most of the teams are actually entering the Builders for Builders program, where they connect directly with a Parachain community or Parachain project or a Parachain team in the end of the day. So for the application track, we're actually more in the coordination phase and making sure that they have the right coordination and connections. But if they are building on to deploy on a Parachain, then they usually go into the Builders for Builders and connect with the Parachain team themselves. And if we're looking at the stages where they are right now, we have around, in the early phase, accepted in 21 coming up into the stream. And the whole stages is for us a way to look at, have a continuous stream of new projects and new teams building in the ecosystem and making sure that they successfully launch a product at the end of the day. So milestone 3, if we look at the milestone 3 and the launch support, we have around 20 teams. And there are definitely like the 10 Parachain teams that are currently connected to Kusama. So this means that the support that we're offering seems to be very successful and very helpful for these teams. So if we're going forward on the projection and what we're looking for forward, the Parachain readiness projection that we're doing. So in this graph, we're showing, it shows like the number of Parachain teams ready to connect to, like, being at the level that they actually have a readiness to connect. So the Parachain team and their code that they develop would be ready to connect as a relay chain, and projecting this over the time frame. So we have this pink graphs are the actually values, and then the two in green, the 2 trend lines. So the upper one is the best case prediction and the lower one is the worst case prediction. And that's something that we're looking into the project and seeing, like, how many teams are in the ecosystem and how many teams do we think are ready at what time point. And this is like gives us a feeling on how much support the relay chain, when it comes to performance and slot auction, slots being available, need to be out there. And just to give a context, these are only the teams in the Builders program. So for sure, there are more teams out in the ecosystem and more teams building Parachains based on Substrate. But these projections based on what was the teams that we see in the Builders program, and where we highly connect and engage with them. And that's sort of like how we projected forward what will happen in the future. So what is happening? What is to expect going forward? For sure, we will double down on the Builders for Builders. Now, Parachains being live, being usable, coming live, going into the Polkadot, aiming for the Polkadot connection, we will help a lot more Parachain teams to get more adoption and get more connection into these Parachain teams, and make sure that we train the Parachain teams with a lot more about what we have learned in the Builders program and help them to build out their product. The second one is security first. So security first means that the Parachain teams or the chain teams that we have in the Builders program have done their, or well prepared for the security reviews, have done initial reviews and know how audits are actually working and what they need to look into, and have also like scheduled their sort of like final production ready audit ahead of time, so they have access to the audit at the time they're going to go to production and going live. At the same time, it also has like this component that we need to ensure that enough audit companies are in the ecosystem and that teams have access to enough audit companies which are able to audit Rust and Substrate code. And the last one is Sub0 Connect. It's a very new initiative that we recently launched. Like, while seeing what the teams, like all these applications to the Builders program, and having like with this vast amount of support that we offer to the Builders program, with like all the technical support, being just able to support the 55 teams, currently we figured out that we need some sort of like scaling the resources up. So in general, the ecosystem Substrate and Polkadot has like a ton of initiatives, like Brian just mentioned a couple of them, where teams at a certain stage can actually access the different initiative, and like we talk about grants and accelerate the hackathon. But it's very hard for a lot of teams to coordinate through the space of initiatives and help. And we want to help these teams to apply for the right initiative at the right time, and go and help them to coordinate through the ecosystem to be, at the end of the day, a successful team that deploys a product in the ecosystem and utilizes all this help in the wider sense. And with that said, I would say thank you very much for your time, and looking forward to connect to all of you and engage. And I will actually move over to the Discord and answer more questions on that.
All right, thank you very much, Ben. We had a couple of questions. First, could you reiterate who to contact if you're interested in the Builders Program?
Yeah, it's
either directly.
Either connect me directly, or if you go on the Substrate IO link where the Substrate Builders Program is explained, there's a couple of links on how to reach out to us and what is the best connection. And I'm in the Discord channel right now, so feel free to reach out.
Yeah. Okay. And a few other questions. So you mentioned, not everyone gets into the Substrate Builders Program. So could you give some ideas on what would help people either get accepted, or conversely, what to avoid to make sure they're not rejected?
Yeah. So as said, the minimum requirement is that you have this least level of development, that you have developed something with Substrate. We call it POC, proof of concept, MVP level. So there is some code in a repo that you can share with us and we can look at it. This is like sort of the minimum requirement. And the second one is have a good outlined milestone, like roadmap on how you want to execute, that we can evaluate on if that makes sense in the context of what you have built so far. And we will help you with the milestones a lot. So rather, if you have built something on Substrate and there is code available, then rather apply for it. And we will help you to set up the milestones. But this milestones is really the minimal requirement that we have for those programs.
Okay, so yeah, it's not like a class where you're looking for problems, but you will help people to develop these milestones and help them to get understand what they need in order to get accepted.
Yeah, exactly. So this is like initially in the intro call, we will give you advice on, we talk with you about what is the project actually about, and then we give you advice on how you should set up your milestone, what we think that should be done like roadmap wise and development wise. And this is like the input then for the pitch call. And the pitch call is like, okay, you have built everything out, you have like lined out how you develop, and then convince us that this is valuable and you are capable of executing on it.
Okay. All right. One last question, and then I will let you get to the Discord chat. Does the Substrate Builders Program also provide support for Substrate projects which may not plan on being parachains? They want to be a solo chain or something different, or is it just for Polkadot and Kusama network projects?
Oh yes. No, it's completely open for anybody who is building something with Substrate or in the context of Substrate. So even if you build a solo chain, we will help you. If you build like infrastructure tooling to make it easier to deploy Substrate chains or wallets or anything like that, we will help you. So in general, one could say everything that is enabling or helping to enable teams building with Substrate.
Okay. All right. Well, thank you very much, Ben, for a really interesting talk. So hopefully this has given some ideas to people out there in the audience that would like to join the Substrate Builders Program. And of course, Ben will be in the Discord after this to talk. Also, just a note, slides are generally available in the individual Discord channels if you want to review the slides as well. So again, yeah, thank you very much, Ben. And we're just going to take a very short break to prepare the next speaker. Welcome back. For our next presentation, we have Han Wen discussing how to build a credit computation network with aggregated identities. Han Wen?
Hi, Bill. Okay, so today I'm going to share my experience on building a credit computation network with the aggregated identities. Of course, it's built on Substrate framework. And for the context, I'm the founder of Litantree and also the software engineer of Parity Technologies. Okay. So let's take a look at the current blockchain industry and see why we raised the idea of the aggregated identity. So firstly, the Polkadot and Kusama has made a great practice of using on-chain governance, for example, runtime upgrade, treasury handling. But in the on-chain governance, we need more identity information for governance, participants, for transparency and interaction. And secondly, the growth of on-chain data are scattered in the different blockchains. As we see more blockchains here, and the new blockchains are coming like every month, right? There's indeed a lot of information. For example, a user could have NFTs on Binance Smart Chain, have been a liquidity provider on Uniswap, and attend a crowd loan in Kusama Parachain auction. And next is KYC alternatives. As compliance regulation becomes more strict, KYC is asked almost everywhere, and it is used to prevent DOT and harmful activities. But does this tedious KYC process the only solution? Actually, we are looking for the alternatives. The last but not least, as we see that Polkadot has its identity palette, and also Ethereum have ENS, Ethereum Name Services. Do we need to input the same information on different blockchains? Repeatedly? Probably we need a one-stop identity solution in the cross-chain scenarios. And to solve these problems, Litantree proposed an idea of an aggregated identity, which is to link the identities you have into one and link the relationship. This linking relationship is actually stored in an on-chain TE environment. This could provide the following benefits for the Web3 users, and also to solve the previous problem. So functionally, it provides the interoperability from one blockchain to another. User could also use one blockchain signers to log into the other blockchain platforms and use the linked proxy accounts to make a payment cross-chain. And also financially, as an aggregated identity provides more info, it could be used as a KYC alternatives for IDO platforms, for airdrop activities, and to prevent the bots, right? And this is the, this is the aggregated identity is used as a KYC alternative. And socially, the aggregated identity could facilitate a better on-chain governance with a more complex profile, and further encourage users who has the similar interest to form a DAO. And last but not least, psychologically, the user, we also provide the dedicated privacy control for this aggregated identity, and it is the aggregated identity itself is also a self-sovereign identity. It is better than the other tools which make all the user information public. And but building a aggregated identity is not an easy job. Not to mention to bring the credit and reputation into the Web3 space. That's why we spend a lot of energy to get great team members. As a result, we have already created some good product, and at the same time, we also are developing, different products to support this idea, this aggregated identity. And our products could be further used for a credit computation. Here we have some example here. So firstly, we have this identity-based push notification, which could enable users to subscribe to some governance activities and also to subscribe to other identities like council members' wallet address. sorry for the cancel members here. And we also have identity profiling services, which could analyze the user behavior with any input address. So I will explain this later. And the single sign-on, and the third is single sign-on, and the interaction with OAuth. This will gain the adoption of Web3 identities into Web2 platforms. I have just submit a Web3 grant application today to the Web3 Foundation about this. And the privacy preserving technologies, which is used to protect the user wallet information, we are building because we are building a sidechain with TE devices to store the sensitive information of the users. And all this leads to the adoption of the aggregated identity. And yeah, there's already lots of tasks to be done here. And fortunately, we have the substrate framework, which could help us and let us to only focus on the identity-related issue on chain. And yeah, though this is not the main topic of this presentation, but let me have a brief introduction on how we build such an aggregated identity. We also use Substrate to do that. The rough idea is that we assign a challenger to a user who wants to link identity into another network. And then this user, for example, like Solana or Ethereum, then the user needs to sign this message and submit like the signature in the network. And in our off-chain worker will then fetch the transaction and validate the proof in the transaction. So if you have already registered a identity in the with the identity registrar on Polkadot and Kusama, this may sound familiar to you because the logic is similar. But our approach is validate the proof on chain. So and also the identity is encrypted, and so no one can see it. It's protected in the TE devices, so no one can see it. I will explain this later as well. And now we have the aggregated identity, but is that enough to provide the background information for this, like IDO, for airdrop, or for device services? No, it's not, because the identity linking information are encrypted in the TE devices, so no other parties could access to it. Even for the owner, they could not get the linking information. So the outside world does not know that you are who you are, or if you are the targeted user, if you are, for example, a active governance participant, they have no idea. So we need a place actually to generate a proof for the in a decentralized way. This is what the literature network. This is where the literature network comes in. And the network mainly includes 3 different layers. The first one is the data source layer, and second one is address analysis layer, and third one is identity aggregation layer. So let's take a look one by one. Firstly, we have the data source layer. This is very straightforward. The layer is provided by various Web3 data services on different blockchains. Just a second. Yeah, okay. Like Polkascan, Subscan, or Etherscan, we need to gather the raw block information and to index the data by the wallet address, like the governance activities, IDO activities, and the access info like non-fungible token or fungible token, right? So this is very straightforward. But at the same time, we are also building our own data indexer to help index this data. Then let's move to the second layer, which is the address analysis layer. The data this raw data are fed into the address analysis layer. There are different data analyzers who provide the computed high-level wallet information here in this layer. For example, this is our front-end UI of one of our data analyzer, which could calculate the label for a wallet as a strong holder, for example, as the high active user, or as a smart money user. Yeah. So in Kusama, we also generated the related score according to users' crawling activities and nominating activities. We also have analyzed some DeFi services, some DeFi activities on the Parachain, for example, on Karura and on Moon River. We also cooperated with some ideal projects to help them to find targeted user and to prevent the bot to get the allocations. For example, we cooperated with Ranger protocol to do this. And the criteria here and the label specified and the label are specified in the smart contract. And actually, we encouraging everyone to set up such a data analyzer. The literature network will curate the results from different analyzers here. And finally, we come into our identity aggregation layer. Our network built with Substrate will generate a credit proof with the information get from the address analysis layer. So here's a flow. Firstly, a user send a credit computation request to the network, and this request is actually encrypted by a sharding key. The sharding key is provided by this TE sidechain. You can see the blue part on the side is our sidechain, and then this task will probably the picture is a little bit small, but I will explain. The task will this task firstly get into the green part. The green part is literally runtime, and then it will be distributed into the TE sidechain. Here, the TE sidechain worker will firstly decrypt it, and then it will fetch the linking identity information from the encrypted on-chain storage. I mean, in the literature runtime. With this linking wallet information, it's the off-chain worker will get the related address information from the address analysis layer. For example, if here I have my literature wallet address, and in the encrypted on-chain storage will get my related, for example, Kusama or Polkadot and the Ethereum wallet information. And then in the TE sidechain, it will fetch all the wallet information from the address analysis layer. And then in the TE worker, it will assemble all these wallet information and create aggregated identity credit. As a consequence, the credit will be encrypted into a proof, and this proof will be sent back to the literature runtime. And the literature runtime will finally send it to the outside world as an event. So here we would like to give some more information about the sidechain. We actually collaborate with the integrated TE team and use Substrate TE network, but not network, sorry, use Substrate TE framework to build such a sidechain. Generally speaking, it wrapped the required palette under a security layer. The request sent to the sidechain are encrypted. All the storage and the execution, cannot be seen by anyone, even by the TE device owner. So the sidechain communicate, and the sidechain also communicate with the literature runtime. So actually, the literature runtime and the sidechain are strong connected by the light client, by the embedded light client. Okay, so also as you can see, we have several different palettes in this identity aggregation layer. As we mentioned before, there's NFT palette. The NFT palette actually could reduce the unnecessary computing for the less frequently changed data, and also to improve the efficiency of the identity data query. Why it does this is because if some user, for example, for the less changed data, user could record this data as an NFT. So next time, the user do not need to send another computing request to the network, and it will cost some money. But instead, he will directly to query if user have such an NFT in his accounts. So later I will make the example. So, but you see here, this is a screenshot of a web web app, we actually provide a platform for project to distribute it NFT as a label for qualified user, and user could claim NFT in our platform and even further merge in two different NFTs into one. So this is some interesting features we provide here. So make a very wide example. So combine like the Polkadot strongholder with a Kusama strongholder to these two labels, you can get a Substrate diamond hand, this NFT. So just for example. Okay. Okay, I see I'm moving too fast. Yeah, this one. Remember, in the data analyzer layer, we have different criteria. They are records in the smart contract, and for example, the data analyzer information, the encrypted identity linking information are all stored here. And by using smart contract, we also get one more benefit is that we could compose the identity scoring algorithm easily. For example, to compose like the two, for example, the requirement of two labels in Polkadot and Kusama to compose them together into one. Okay. Yeah, as supplement, we also build awesome front-end application to help people to interact with our runtime and their identities. For example, we built the micro profile to show user owns NFTs on social platform. We start with Twitter and Ethereum, but Kusama will follow up soon. And we also built the web application. I already showed the screenshot before, but the app application is still in development. The features are identity hub for user to manage its identities. And we also built an app for user to easily participate the governance with mobile devices and get push notifications and enable user to interact with the identity related features. For example, you see on the screenshot, a user could register his identity, see the identity info here. It's now, I mean, the demo app works on both Polkadot and Kusama. It's still in development, but we are, gonna release it soon, I think. Yeah, so thanks to the Substrate framework, we create this credit computation network and realize the interoperability with the aggregated identity. And also we achieve the composability and help user to protect the privacy and use actually the Polkadot and Kusama to ensure the security for our blockchain. Yeah, that's pretty much of it. And thank you, everyone. And it's very happy to be here. And thank you, Bill. I think I will keep to answer the questions in the Discord channel. Right.
Yeah. So thank you, Hanwon. We have actually a couple questions I was hoping to ask you before you head off to the Discord channel.
Yeah, sure.
So first, and I think this was a little unclear. So is lit entry going to be planning to become a parachain along with the sidechain? So there'll be like a parachain with this runtime and then the sidechain?
Yes.
Okay.
So we will have our runtime as a parachain, and we also encouraging other people to contribute to this sidechain and to set up this sidechain. But because the sidechain is connected with the literally runtime with the light client, so the security of the sidechain could also be ensured.
Okay, excellent. And you had mentioned, this is compatible. You can get information from Polkadot, Kusama, Ethereum. Are there other networks that you're looking into, or is that to adding, or are those the ones you're staying with for now?
Yeah, of course. for example, the identity linking pairs, we start with Bitcoin and also Ethereum. And because we are EVM compatible, so I mean, lots of blockchain could be aggregated here. For example, the Polygon, for example, Binance Smart Chain, it could also be aggregated here. But we are also exploring some new potentials like Solana, yeah, at the moment.
Okay. Wow. Excellent. So something you mentioned that I was really intrigued by was OAuth integration. I've never heard of a Web3 ID being able to go through OAuth, but I may just not be aware of them. Is this a first?
I don't know actually. I checked some practice and some papers, but I didn't find there's something already done here, because the things is that we use this OAuth and also enable to use it with the self-custody wallet. There's some platform that you can log into you can log in with your email, but finally you will the wallet will be hosted by the platform, but not hosted by you. It's not fully decentralized. So I think this is something I haven't seen in the industry before.
Okay, yeah, I'd never have either. I thought that was really interesting and a great bridge into sort of the traditional Web 2 world using Web 3 on top of it. So that's really exciting. So the last question we have from I think it's very cool. I have one more question from one of the audience members. So how could you give an example of how this can be used to help people avoid having their identity analyzed? Like how this can be used? Could you give an example of how it can be used to protect privacy?
Actually, we didn't protect the privacy, but there's several different products. For example, Nansen, they're already building something like the profiler, or do analytics could analysis the wallet activities. But this also, as the address is public, everyone could analysis a single address, right? But no one have built a profiler for aggregated identity. This is because no one will want to publish this information, and also we do not want to, against the Web3 spirit, like to publish users this kind of information. But actually, we create a new use scenario that the user could benefit from it. Could get a complex profile, but still keeps this information in privacy. Nobody could access this your wallet graph. Nobody could access they get the relationship between your wallet addresses. So we still in the Web3 space, but we create a new use scenarios to this is to say, but we didn't to leak user information to do things like this.
Okay. All right. Well, thank you very much, Han-Wen. We appreciate your time, and this is a very interesting talk. I certainly learned a lot. So please, everyone, just hang on for a few minutes while we prepare the next speaker. Hi, welcome back. Our next talk, we have Lohan, who will be speaking about how to build an optimized and economically secure parachain. Lohan?
Sure, thank you very much, Bill. So nice to meet you guys. I'm Lohan, blockchain engineer at Engine. And today I would like to talk very briefly about our experience building the Affinity parachain. But before talking about Affinity, I would like to very briefly introduce Engine and why we have decided to build the Affinity parachain. Engine is a company that exists since 2009 and have a lot of experience in the blockchain, NFT, and gaming background. Our CTO, Vitek Handomsky, is the one who proposed and drafted the ERC 1155 standard. And also, I will talk about the ERC 1155 very briefly, but also Engine have made lots of contributions in the blockchain ecosystem, creating things like wallets, SDKs that make very easy for other game developers or third-party companies integrating their ecosystem with the blockchain. So now let's talk about the ERC 1155 standard. For who doesn't know, the ERC 1155 is a multi-token standard built for the Ethereum network. It reduces a lot the transaction fees, and it's basically allow us to implement both fungible tokens and non-fungible tokens under the same spec. And regarding to that, now talking about Affinity. Affinity is a parachain that has been built to be the best in class for trading and make NFTs. Basically, the goal is to turn NFTs and trading assets far more accessible than what we have right now. We want to basically allow batch operations, reduce a lot the fees, and create the best-in-class blockchain for NFTs. That's the goal of Affinity, in short. So our team, we select some topics that I would like to share with you guys, things that we learned when we have built that parachain. So the first one, I would like to talk about how we prevent economic attacks and what are economic attacks, how we keep the storage clean and compact, and some optimizations that we did in our parachain. So first, let's talk about how we prevent economic attacks and what are economic attacks. So there are two kinds of economic attacks. For example, DDoS attacks that we can, for example, shut down nodes by sending a lot of transactions with low costs, for example, or even state bloating. To explain what's that, basically economic attack is when the costs of process operation, for example, a transaction, is is actually high than the costs of send a transaction. Let's say that a node to process a transaction spend $1, but the cost in fees that you pay for the transactions is 10 cents, for example. A malicious user can exploit that and try to increase the storage. So just to provide more context on that, let's see some real example of economic attacks. So in this graph, you can see a list of Ethereum hard forks. And there's two that I would like to point out, the Tangerine Whistle and the Spears Dragon. The Tangerine Whistle was a hard fork that fixes the fees for storage operations, read and write storage. The cost was too low, and basically there's people start to write some smart contracts operation that exploit this behavior and start to spend a lot of I/O operations, which slow down the network a lot and shut down some nodes. So it was the Tangerine Whistle, and like 1 or 2 months after that, they also released the Spiral Dragons that basically clean up the storage because it was too cheap to create accounts and basically store data in Ethereum. So it was a hard fork that they made to fix that. And another example is UTXO in Bitcoin. In this graph, you can see that the growth of UTXO in Bitcoin. And a lot of those UTXO are not actually, it's not because of the popularity of Bitcoin. Some of them are related to that, but some of them is what we call dust. It's basically is a very, very tiny amount of Bitcoin that are allocated in some UTXOs. And basically the nodes need to keep that in memory. That blows the states and require more resources from the nodes to process and run a full node of Bitcoin. So, and in that graphic, we can see, for example, in the blue line, we can see the number of accounts in Ethereum from the entire period for the last 5 years, I think. And in the black line, we can see the average of Ether per account. So we can see that actually the number of accounts have been increased, but the number of Ether per account has decreased. And again, that consumes a lot of resources from the nodes. Basically, the developers from the nodes have to create a lot of clever stuff to mitigate that that does not use a lot of memory for storing this kind of data. And in Substrate, as you guys know, one way that Polkadot and the asset balance provide to mitigate that is providing the existential deposit, where the account needs to have a minimum amount of tokens in order to exist. So this is a way for preventing this kind of attack. But there's also other attack vectors. For example, let's say that you create asset storage. You create something that store data in your blockchain. It's not, you also need to worry about if you are increase the storage size, that thing you need to charge the fees for that. Otherwise, it will become attack vector. So one way that Substrate provides to us to deal with that is the way that, for example, the assets and the uniques palette deal with that is a config where you can define the base deposit and deposit per byte. The base deposit is basically an amount of tokens that you need to allocate in order to create a new asset. And the deposit per byte, let's say that you want to store some metadata in your token, is a fee based on the amount of data that you want to store in your palette. Those parameters are very important because it's a way to prevent economic attacks in your chain. Because if your chain starts to grow indefinitely, the nodes will require more memory, require more resource, and people will basically stop working. You can basically stop working your chain completely if you don't take care about that. Now I will talk very briefly about the storage cleanup. You need to charge the fees for storing data, but you also need to clean this data. Let's see, that is more tricky than it sounds. Let's see why. So in this example here, I have two storage. One that we basically keep the assets, and we have the attributes associated to this asset in the second one. So basically you can think like we have a table of assets and another one with the attributes associated with that asset. The trick thing is when we need to delete an asset, for example. In this case, that's a very bad way to do that. When you destroy an asset, you basically remove that, and you remove all attributes associated with this asset, and you do not take account how many attributes you have per asset. Remember that an attribute is a mapping, so you can have like 1 billion attributes associated with this asset. And if you don't take care about that, if you don't charge the correct fees for that, basically one transaction like that can block your blockchain, because it's going to use more weight from a block than a regular transaction. So a better way to do that, for example, the most simple solution is, for example, charging the worst case scenario. So let's say that you can have up to 20 tokens per asset. So you always charge 20 storage reads from the user. You can see the parameter in the extrinsic decorator there. And you reimburse the user. Let's say that it was only 10 attributes. You can reimburse the user from the, you charge 20, but you can reimburse the other 10 that he does not delete, for example. But the bad thing about that is that we always charge the worst case scenario. So let's say that you want to allow like millions of attributes for this token. So that's not a good solution for that. Another one, that's the one that I think that Parity Unix is using, is providing what we call a extrinsic witness. So basically, when you send a transaction to delete a token or do some storage operation that you need to clean up your storage, you can provide, for example, a tip of how many tokens you have associated with this attribute. This solution is good because you charge the exact amount of tokens that the user have, but have some downsides of that. The user who call this extrinsic needs to know how many attributes are associated with this asset. And if for some reason it's out of sync, you can see in that ensure statement, this transaction is going to fail. So if for example, the user said, okay, have 10 attributes, but when your transaction is processed by the node, that amount changes, the transaction is going to fail in that case. So this, for example, is only advised if the attribute, for example, count does not change a lot. So this is one way to mitigate that. And the other complication that have associated with that is the smart contract integration, because smart contract needs to know the state of the token, how many attributes it have in order to delete that. Another solution for that is lazy deletion. That's the approach adopted by the smart contracts repo. In this approach, for example, you delete a token and you put that in a pending pool. So for example, there's a new feature for Substrate where you can use on idle hooks for cleanup this data. So the good thing about that is that you always have a constant weight price for cleanup the storage using this approach. So in one block, you delete the asset, and only if there is some remain weight in a block, it's going to delete the data. And last but not less important, we also can have some economic incentivizes for cleanup the storage. This is a good example of that is also the smart contracts. If the user don't pay a rent, or there is a lot of pending contracts that need to be deleted, basically you have a extrinsic that you can call to delete this contract. But instead of paying for that transaction, you are actually be rewarded for that. So if you successfully delete the contract, you are getting rewarded for that. So you can use that approach also. Okay, cool. And now let's talk about the optimizations that we did in our Parachain. One of the biggest issues that other blockchains are facing right now are the very high cost of fees for manipulate NFTs. Vitalik even suggests moving all NFTs to Layer 2 in order to deal with that. One of the guilds for the very high cost of transaction fees in Ethereum right now are NFTs. I checked that today, and it's up for doing a simple transfer of ERC 721 token. It's about $20. So it's not very accessible. We cannot make NFTs mainstream with those very high transaction fees. But let's see why it's so expensive to manipulate NFTs in Ethereum and in other blockchains. So very briefly, the way that Substrate and other blockchains represent the data internally, they use a data structure called basis 16 modifier Merkle 3 or Merkle Patricia 3. In this example, we can see the structure from Ethereum specifically. Polkadot have a slight different structure. They don't have extension nodes, only branch and branch extension and leaf nodes. But that's how Merkle 3 looks like. But a simplified version of that is that one here. So this, for example, is how the Parity Unix represent data. So we have a path in that Merkle tree that represents the asset. And we have at the end of each node, we have who is the owner of that NFT. So in that example, let's look at the first NFT there. So for example, the NFT 0x97B96B07A. That's the NFT ID, for example. The owner is Bob in that example. When we transfer that NFT, we actually need to update all those nodes in order to change the owner of that NFT. And that's even worse when you need to do, for example, a batch transfer. Let's see that John wants to transfer all its NFT to Fred, for example. In that case, it needs to update a lot of nodes, and each one of them, it means that we need to reach the storage, update the owner, calculate the hash of each one of those nodes. And that's really expensive, computational expensive. And in Infinity, we want the ability to mint not 100, we want to mint millions of tokens at once. We want to transfer billions of tokens at once. So using that structure, that's not possible. And just for example, the real Merkle tree structure that have millions and millions of tokens will look more like that. It's actually, there's a way to fit millions of tokens here. So this approach does not scale. So one thing that we did in Affinity for optimize that, and is one thing that Substrate allows us to do, is optimize, change the way that we actually store this data. So instead of storing one owner, one NFT per node in that Merkle Patricia tree, we are actually doing what we call a chunk. We can compress like 100,000 NFTs in one node. So when we upgrade that node, basically we can manipulate 1,000 NFTs with just one storage write and one storage read. And another thing that we are doing, instead of the blockchain is asynchronous. A single blockchain works synchronously. So instead of allowing the user to provide, for example, I want to mint NFT with that number, we have a sequence number. So these things basically allow us to, for example, mint millions of NFTs in a single transaction. That is not possible in Ethereum. That's not possible in any other blockchain. So just to show you guys some benchmarks in comparison, the base implementation that was inspired in Parity Unix, we can see in the first graph how many weight we use for the first implementation. For example, we can even see the graph of the storage optimization, because it was like 5,000 using like 5,000 less weight than the common implementation. and same for batch transfer and single NFT transfer. The only downside, we have a little degradation performance for single transfers, but the benefits of minting many NFTs at once and transfer that then in batch basically suppress those drawbacks. So yeah, it's pretty much that, and let's open to questions. Thank you very much.
All right. Yes. Thank you. Thank you very much, Lohan. There's a couple of questions that we had here. I'm especially curious. You had mentioned wanting to handle, very large numbers, millions of NFTs, and I know this question is probably going to come with a lot of caveats. But do you have any estimates on how many you can handle, theoretically on your chain? Like how many NFT transfers in a given amount of time, or?
We don't have this number because, for example, right now the block weight for Parachains are coupled by 50 milliseconds, and we actually need. It depends there's a lot of variables on that. In your benchmark tests, using the tools that Substrate provides to us, we only have a direct comparison, and we achieve like 50,000 improvement for that. It means that using the same transaction, we can improve like 50,000 more NFTs using the same weight. We have that in our website if you guys want to see details how we did that.
Okay, yeah. Yeah, I definitely would be interested in looking into that. And so getting back to the earlier part of your talk, and the economic attacks against chains. I mean, we know they're very common. I'm curious, do you have any thoughts on how important or how prevalent those are compared to other, perhaps more traditional attacks?
The problem with economic attacks is that people usually only worry about them when they happen. So, and when they happen, it's a pain in the ass. For example, Ethereum had to do 2 hard forks, emergency hard forks, in order to fix that. So I think that it's better to you charge a high fee, thinking the worst case, and decrease the fees if you find out a way to solve that in the future. So yeah, that's my tip. Don't prevent economic attacks before they happen, because when they happen, it's terrible.
Yeah, and I guess very unexpected and often like black swan like to determine. All right, well, thank you very much for a very interesting talk. So we will now be taking a break. So please make sure to use the time to either network or just sit back and enjoy the music. And when we come back, Branimir Rakic will be giving a talk on Semantic Substrate, building with the decentralized knowledge graphs. Welcome back, everyone. I see from the chat that people were enjoying the music quite a bit during the break. Hopefully you also did some networking. We have with us Branimir Rakic, who will be discussing Semantic Substrate, building with decentralized knowledge graph. So Branimir, please take it away.
Thank you very much. Thank you. Hi, everybody. So my name is Branimir. I'm one of the founders and the CTO of Trace Labs, who are the core developers of Origin Trail. And today I'll be speaking a bit about what that means for Substrate and what particularly building with the decentralized knowledge graph means. So I'll jump really quick into a bit of evolution. I think we all kind of know this, but I want to restate what it meant to go from the original Web 1, which was about document exchange, all the way to today. So we kind of transitioned towards this Web 2, which was about web of interactions, or the social web, or basically we all kind of live today, and we all know that social networks tend to use and sometimes even abuse a lot of the data that we actually get to exchange over the internet. So it's no longer just document exchange, it's really about interactions. And then Web 3 was all of the stuff we're talking about here today. But actually, I would like to say that it's a little bit wider than that. Web 3 is actually about meaning and value exchange, or as it was originally dubbed, the semantic web. So apart from obviously asset ownership, data ownership, identity ownership, as we've seen in a bunch of the presentations prior to this one, it is about value exchange, but as much so also about meaning. And actually, we heard about this from Tim Berners-Lee himself, the inventor of the World Wide Web, who actually gave us a technological stack for it. So he invented this layered structure of the semantic web, or what he called Web 3, 20 years ago, with some probably very familiar components such as URIs, cryptography, obviously, but also some very interesting ones which are targeted towards semantics and meaning, such as ontologies, query languages like Sparkle, data interchange formats. And then finally on top, like as the icing on the cake, he sort of put a layer of proof and trust, right? And although he was very visionary at the time when he was making this, we didn't have what we have in the Web3 today. So all of the trust protocols that we're all building together. And what we would actually like to argue that it was that he got it right. We just have much better tools and a better idea of what Web3 looks like today. But basically, if we talk about this trust, I'm not going to explain what blockchains are. Trust me, I'm sure everybody knows on this on this event what blockchains are. But I want to emphasize in one sentence that they are trust networks. And basically that means we have decentralized stateful protocols compared to, for example, HTTP, which is stateless. So we have stateful protocols where we share verifiable state somehow among us, and then we are able to build on top of that, including applications, all kinds of smart contracts and goodies that we've seen over the course of this event. But just as blockchains are trust networks, knowledge graphs are semantic networks. And that means basically that we're no longer talking about strings, we're talking about things. And in that sense, we're moving from this notion of raw data to actually highly structured knowledge. And companies such as Facebook, Google, eBay, Amazon, all of these Web 2 giants have been using these technologies, knowledge graphs or KGs, to extract value from their platform's data. It's basically the data structure that is the core of their business. Amazon uses it for recommendations. Google uses it for search, also to learn how to improve its own search, basically all on this layer of semantic, machine readable and machine understandable data. So, all right. At Origin Trail, what we really are doing is we're building the world's first decentralized knowledge graph. So what does Origin Trail then do? Well, basically, it's organizing humanity's most important assets, making them discoverable, verifiable, and valuable. And in a sense, it's the decentralized semantic layer, which is synergizing knowledge graphs and blockchains, merging the value propositions of the two. Actually, today, Origin Trail is already a live network for several years. It's a permissionless network. It's completely open and open source, and it's run by over 2,000 different participants or people running nodes around the world by the Origin Trail community. And essentially, the way Origin Trail works is that it connects to multiple blockchains. So it's by itself, it's a decentralized knowledge graph. It's not a blockchain. And currently, it actually interoperates with Ethereum, XDAI, and Polygon blockchains. Soon, hopefully, as well with Polkadot, on which we've been working for quite some time, both through the Substrate Builders program, but also through our own internal projects. Now, the point here is that the decentralized knowledge graph provides this layer of semantics, which together with all of these blockchains that it interoperates with, enables the utilization of the power of knowledge graphs in Web3 applications. Now, going a little bit into more details, what this means is that we have highly structured, machine understandable, verifiable data. And essentially, this decentralized knowledge graph represents an interlinked collection of verifiable assertions or claims, which are based on URIs or DIDs. For those of you familiar with DIDs, you know that those are interoperable. But for those of you who are not, DIDs are basically the decentralized version of identifiers that are formally actually defined by W3C and the semantic web community. And essentially, they enable identity ownership. But also, apart from this, the whole point of this knowledge graph, actual interconnectivity of data, is semantic representation. So the ability to represent information in a highly structured way as graphs. And that comes down to really focusing on creating something called data triples, meaning subject, predicate, object relations, or subject property object, as some people call it, where essentially you're able to explain, let's say, or describe any sort of interaction. You could, for example, say that subject, myself, Branimir, is giving a presentation, which is an object. And through this very flexible system of triples, you're able to basically generate graphs of anything. Now, in these triples, you use these identifiers, which are DIDs or URIs, to actually make sure that you refer to the same entities. And this enables data integration and actually vast growth of data around a similar asset or object. All right, I think I lost. Oh, no, I didn't. All right, all of this is tied in together with verifiable credentials. So, which is another W3C recommendation, essentially enabling verifiability of these claims. And for the decentralized knowledge graph, that is actually done on the level of the graph. But basically, that means we have a global asset knowledge graph, which essentially has a decentralized public index, which is used for discoverability. So think of what was Web 2 Google index, where Google goes around and scrapes the whole internet and somehow indexes this information, so it's easier for us to use it for search. That is the decentralized public index. That is the function, in a way, of what the decentralized public index does in the decentralized knowledge graph. Also, private data graphs. So not all data is public. The ability to actually connect privately held graphs into the same knowledge graph is one of the key properties of the decentralized knowledge graph. So, which actually quite a few enterprises are using. Yet again, still getting the verifiability and discoverability features that they need. And obviously, having cryptographic proofs then available on chain. So the data in the graph itself is in the decentralized knowledge graph network. However, the proofs are available on these chains. And with these proofs, you can do quite a few interesting things. For example, verify that a certain timestamp data set has had a certain form or piece of that data set, or more precisely, information about a certain entity or asset. And that could be verifiable directly into a smart contract, because these actually Merkle tree proofs are available. And And then finally, graph services, which are one of the coolest things around, which enable all kinds of great things, from things like Google PageRank, which is quite an old I believe, known thing, but also all kinds of NLP and even going into ML-like things where the actual base of this is all in the graph and highly structured. So basically, we have knowledge graph queries with blockchain powers. So what can we do? Well, we can query the network for asset graphs. That means we can resolve by DID, or we can search by keywords. For example, a certain asset like an NFT could have associated tags, and you would be able to search it by these tags, or identifiers, or any type of interesting values. But also just generally shoot any fully fledged queries. Think of your old school select star from something in SQL or GraphQL queries. And actually GraphQL and Sparkle are what is coming up in the next version of Origin Trail. And with this, we're able to query any single asset in the graph in several different ways, but the last fully fledged query one actually enables all kinds of various basically extractions of knowledge from this knowledge graph. So what actually we are able to also get here, apart from the queries, is to get asset integrity proofs, verify this in off-chain or on-chain, but also in the off-chain module, which I'll present a little bit today and let you know that where you can see it. And if you look on the right, you'll actually see a very simplified, basically interface where through the what we call the DKG client, you're able to publish and query the decentralized knowledge graph either throughout the whole network, or actually query for a history, or what we call the trail of a specific object, hence Origin Trail. So, all right, let me load this already. So essentially what we have built so far for Substrate, and which is available for all Substrate chains, is a very new DKG decentralized knowledge graph off-chain worker palette, which can be used by any Kusama or Polkadot chain to query for assets or to publish assets data to the decentralized knowledge graph, and then being able to use it in the other direction, so to query it in the ways I just described for verifiable assertion graphs, meaning data and proofs, and then doing one of two very wide concepts. One is actually process all this, verify this query result, and propose and do some action off-chain in the actual off-chain worker palette, and then submit the result in a transaction extrinsic to the runtime, or actually go ahead from the get-go and submit it in the runtime and verify it in the contract, and actually execute some logic based on that. We actually have the first version of the DKG off-chain worker palette available on GitHub. I'll show the link very soon, so you can go check it out. But just to give a bit more context, what this could be, for example, the previous presentation where we heard Engine talking about NFTs, think of the Engine or Engine-like chain querying for asset or NFT information that is highly structured in a graph hosted on the decentralized knowledge graph, or Akala applications who actually submit either this information to the graph and index it in that way so that it's easily usable and discoverable, and vice versa, ingest information in an Oracle-like fashion from the decentralized knowledge graph. How am I on time? I have about 10 minutes, right? With questions. Okay. So moving forward, the DKG off-chain worker palette, what it basically does, it implements the support for the decentralized knowledge graph API, and it is prototyped with the Origin Trail Parachain implementation, which we've been actually working on for quite some time. It is actually an EVM compatible parachain, so we're also working on that compatibility. There's also a Rust crate available that is completely separate, but also highly usable. And in the coming roadmap, what we are working on is, as mentioned, compatibility with the EVM palette, provisioning verifiable credential graphs directly from substrate-based chains. So basically anybody running Kusama or Polkadot parachains would be able to provision these highly structured graphs and take the load off the chain while still remain verifiable, highly structured information available to it. And obvious next step is really data marketplace support. So we've been working on much of these protocols so far, one of which is actually obviously fully decentralized implementation of something called FairSwap, which is the ability which gives you the ability to trade data for tokens. Well, in this way, what we get unlocked further is the set of knowledge tools, which are there to enable knowledge marketplaces and these queries to be payable. And in that sense, getting the ability to both monetize available data as well as to synergize or actually crowdsource new data based on the queries in the graph, much like Google is using the query analysis that also is available through the decentralized knowledge graph. Finally, a lot of this comes together with support for Origin Trail v6. So we're entering version 6 this year, and we're very excited to be releasing that, including the Sparkle GraphQL and other supported new goodies coming. But anyhow, not to stop too much there, basically you can just go ahead to our GitHub, you can check it out, you can find the code for the off-chain worker palette, and you can give it a go and test yourself. And if you'd like to get any assistance or have any questions, feel free to approach us either in Sub0 chat or our own Discord at Origin Trail, which has quite a vibrant Origin Trail community and a lot of node runners around. So there will be definitely people to support you. So what can you do with Origin Trail? Zooming out a little bit. You can build with semantic, high-quality verifiable data, as explained previously. You can also publish verifiable claims as much as any other data knowledge graph publishing is happening, but in a centralized way. What is really powerful is then we get the ability to integrate data easily across the Web3 and seamlessly, especially in Web3 where sometimes there's a bunch of shared identifiers around. So identifiers such as cryptographic hashes, the ability to integrate this is one of the core capabilities of any knowledge graph, and especially the decentralized knowledge graph. Then easily build privacy-first, metaverse-ready apps, the ability to discover and crowdsource high-quality data sets, as I said. So basically think of the capability to look for something very highly structured and meaningful for your particular use case. You'll be able to actually ask the community to crowdsource that. And then finally, tokenizing the dynamic assets, tokenizing these asset graphs, which are in themselves attached to the assets that they are describing in this semantic way. Now, the core concept here is that Origin Trail actually operates on the network effect. So the graph synergizes data and actually makes this even more valuable. So as information is inherently valuable, connected information is actually more valuable. So the decentralized knowledge graph unlocks this Metcalfe's law of network effects. The network effects meaning that we can actually discover this, we can verify all of this data, and we can assess the value of all of these represented assets. And if you haven't heard of Metcalfe's law, this on the right, you can see it. It says that the value of a network is proportional to the square of the number of participants in the network, which has actually been proven many times ever since the inception of Ethernet, which was created by Bob Metcalfe, who the law is named after, and who is, by the way, one of our advisors. But also other networks such as social networks, Facebook growth. You can correlate basically the growth of the number of users in Facebook with literally this function, which is very proportional to the growth of their revenue. And many other proofs, not to go too much into Metcalfe's law. What we aim here is to harness the network effects on the data level. So integrating all of this and using it in the way Google, Facebook, Amazon, and all these big Web2 companies have managed to use it, or sometimes even abuse it. I also want to add a small quote there for the co-founder of Intel, Robert Noyce, who actually says that knowledge is power, but knowledge shared is power multiplied. And that is exactly how we see the network effects in knowledge graphs. Origin Trail is already being actually used in quite a lot of places, including the British Standards Institution, Swiss Railway Company, the SCAN Association, which encompasses the global biggest retailers such as Walmart, Target, Home Depot. We have a lot of interesting material on if you're interested in seeing how they use it. And this is, by the way, all production use cases. So Origin Trail has been proven quite a lot. And there's also quite a lot of support by organizations such as Walmart. We got their Food Safety and Collaboration Center Award. British Standards Institution is we're their exclusive partner for blockchain technologies. Oracle and the World Economic Forum have also been supporters of Origin Trail, and actually World Economic Forum helping a data crowdsourcing campaign for trusted COVID essential supplies during the pandemic. Anyhow, it's not just for organizations. This technology is, like I said, again, open source, permissionless. It gives the power of Web2 giants that have knowledge graphs to the decentralized world, and anybody can use it as long as they're able to basically have the value from the data that the vast Web3 is actually constantly growing and cultivating. With that, I'd like to finish and invite you on to join us on this journey of going really from this Web 2 to the semantic Web 3 and adding more knowledge into our systems, into moving from strings to things, adding them value and making them discoverable, verifiable, and finally valuable. Thank you very much. And yeah, for more information, feel free to ping me anywhere, Twitter, Discord, and visit our website. Thank you.
All right, thank you very much, Branimir. We actually have quite a few questions. We're not going to have time to get through all of them, but I do want to go through a few. First off, one person had asked about when Sparkle support will be added. I think you said in V6, but was there a date or approximate date given? Or did I miss that?
Yeah, so I didn't mention it, but the aim is to release the 6.0 version of Origin Trail latest by the end of this year, and that will contain Sparkle support from the get-go. So hope that satisfies the audience.
Yeah. And if not, I guess they can reach out to you as you already mentioned.
Absolutely.
We had another question about the data storage capacity. Like as the distributed graph grows, like what has been like the size of the data? Like how fast has this been growing?
Yeah, that's a very good question. So perhaps before just jumping into the size, a little bit about how data is managed. So just so a lot of people ask us and think that the centralized knowledge graph operates the same as a blockchain and then kind of replicates all the data all over the place at the same time. It's much more akin to, let's say, IPFS in that sense, but as well as content distributes according to content address around the network and then replicates it with a fairly large replication factor. And in that sense, saves a lot on capacity. So we don't necessarily have the same constraints as in blockchain. And the graph has been growing quite significantly in the last year. What we use for the metric, though, is not necessarily data, which is quite big, but it's actually something we call total graph size, which aims to measure the amount of knowledge in the graph. So not just raw data, not just, let's say, kilograms, but rather how many connected entities we have in the graph. And the total graph size actually counts all of the entities and all of their connections together. And if I'm not mistaken, it's close to 70 million right now, which is quite large for such, let's say, a young knowledge graph. and yeah, it's growing steadily. I think it's during this year we should see around 100+ million entities basically in the graph.
Wow, quite impressive. Well, thank you very much, Branimir. As I mentioned, there were quite a few questions I couldn't get to, so I'm sure you have your work cut out for you answering them.
Thank you very much.
Again.
Yeah, feel free to shoot any questions in the Discord. I'll be around.
Okay. And yeah, thank you. And please just hold on for a few moments while we prepare the next speaker. Welcome back, everyone. For our next presentation, we have Maciej giving a presentation on composable interoperability built with Substrate. Maciej?
Good evening from Berlin. Yes, thank you for having me here. Indeed, today's talk is all about composable interoperability built with Substrate. And it's also my attempt to give a technical overview into a system we create to facilitate building and executing smart contracts into multiple chains, therefore interoperable. There will be a couple of examples of interoperable smart contracts moving further. But before we dive into this, I would like to paint a picture of where smart contracts stand now when it comes to composing execution cross-chain, and also hopefully it allows us to understand a bit more a couple of architectural decisions we made creating the system. Any product really that does execution around smart contract is expected to come with two properties, being fail-safe and composable. Composability gives us this nice effect where we can cascade these solutions based on the blocks we already have. And fail-safe, meaning we are, even if execution is broken in between multiple steps, there will be no side effects in the form of some unfinished transfers on the chains that we create. On top of that, there is additional twist that we are building into Turn, which is on-chain rewards. And this comes from two origins. The first origin being we would like to be involved in adding additional push to open source developers, giving developers chance to be remunerated for the work they are doing. And also, it also comes from the fact that building a new solution in Substrate really gives us an opportunity to design the economy of a system from ground up, meaning that we don't really inherit any economical boundaries that are happening let's say, in the other platforms where all of the fees would, in most of the cases, go either to miners when it comes to proof of work services or validators for proof of stake consensus systems. Here in this case, we would like to create a system which gives developer to really build out a new underlying economy of their own smart contracts and decide what would fit best into their specific solution. The smart contracts all will be hosted in the architecture thing, which we call on-chain contracts repository. And physically, it's nothing else but a palette built out with Substrate that is storing the, for now, WASM binaries of the contracts that come to us, and at the same time is able to track and pay-per-use for all of the executions. We do believe it's important for us not to give too much of requirements for developers and leave them a freedom of how they like to create their own smart contracts. Therefore, anything really that compiles to WASM is fine with us. Developers could still write their contract in Rust using Ink, the smart contract languages for Polkadot ecosystem, or stick with Solidity or assembly script. To illustrate really the use cases that has been proven very powerful of smart contracts and its composability, it's worth to consider the DeFi blocks composability. On the example here, we see a custom trading logic, which is connecting together 3 consecutive calls. First of all, it swaps one pair, then it feeds it to a liquidity pool. Then, given the LP tokens, it feeds the LP tokens to another smart contract that would generate APY in some sense. When it's happening all of Ethereum, creating smart contracts with Solidity really comes by default with this very functional feature, meaning, let's say, in case there is an error in the second step out of 3, in case we run out of gas, let's say, while adding liquidity to the pool, there will be no side effects in the sense that the swap will also be rolled back. So in turn, we attempt to really make this very specific case of DeFi blocks at the same time more generic and at the same time elevated to a multi-chain layer. And when we think of some additional use cases that can be composed of one another, it's easy to see that the examples that we'll be showing in the later parts of these presentations, it's relatively easy to compose together not only DeFi blocks, but executions in general, compose the modules from decentralized governance with decentralized data or autonomous organizations. So if we would like to simply elevate the smart contracts to a cross-chain level, we would simply realize that it's becoming more difficult because we need to abandon sort of the synchronous way of developing a smart contract if we would have done it, let's say, in Solidity and Ethereum, where we can simply rely on the values that we calculated a bit before in the smart contract execution. And we are relying on the fact that physically all of the data that is necessary to calculate the smart contract, both the smart contract code and underlying state, sits on the same machine. In the example here, we would elevate the computation of a single value to the cross-chain case. And now we need to start dealing with the fact that at the same time, we would like to update a value that resides on another chain. There could be another actors involved in updating the same smart contract in a similar time, and we really have no control over the order of how would those informations be saved on a foreign consensus system. So state reads are becoming asynchronous. at the same time, handling errors becomes also quite problematic when we are dealing with the fact that smart contracts execution is now composed out of blockchains, which are in its nature immutable. So keeping the previous points in mind, in turn, we really like to think of our smart contract to be closer to a state machine which has an input. The results would depend on the input and also on the local execution state that would be present throughout the whole execution of interoperable transaction. We abandon the instantiating step that is present in most of the smart contract systems. And instead, we would now carry on with passing the state throughout the next steps, with at the same time coming with the whole blockchain setup that would give in an open way sort of an insurance over execution, where all of the parties would be able to participate in the execution and acting accordingly to the protocol, pass the messages between different chains. The messages that will be passed between different chains from now on are we calling side effects, and those are really the commands, the operations that needs to be now delivered into different chains, and also based on how developers wrote the smart contracts, there can be some dependencies into order in which side effects will be passed on and proofs relied back to the circuit. So this is pretty much where we arrived at now. We have a circuit, which is a blockchain that is able to both store a couple of composable contracts and is able to trigger the execution of those, at the same time producing side effects that in the later parts would be delivered into foreign consensus systems. It's important to notice perhaps that trigger in our design is something pretty generic, meaning that it could either be a call, a simple RPC call, but not necessarily. It could be a change on a different account, or a message passed from XCM when it comes to integrating with Polkadot ecosystems. So the first example showcases how we could freely move within a smart contract and pass the execution over Polkadot and Kusama parachains. In this example, we would see that after receiving an XCM message trigger, the execution of a custom trading logic will fire and would also receive some additional data from Ethereum, use those data to calculate the exact values that then will have to be swapped using a Karura, and then with those two additional transfers, we would also perform them in a native way to both Karura and Kusama. So we arrive with a system that is able to pass the messages and at the same time gives a fail-safe guarantee that all of the steps that we wrote within a smart contract will come as an atomic operation. The next example demonstrates the use of another trigger, another than XCM, where it's possible to register an observer that would observe a particular account on a foreign consensus system. Here in this example, it's a blockchain. And the example really is meant to showcase that the system we create is meant to be adaptable and work alongside with many consensus systems, and therefore we believe useful. The smart contract logic we see on the slide is doing pretty much something similar to what we saw on the previous example. Also some custom trading logic, receiving amount of value in Bitcoins, utilizing the price that would be proved to be already already valid from Ethereum, utilizing this price to calculate several swaps and transfers to Alkaline Ethereum. So the previous two examples, they were relying on the assumption that we'd really like to treat the execution as an atomic transaction and make sure that all of the steps would go within the transaction or none at all, and the side effects would be cleaned up throughout the different chains. In this example, we see that we also could rely on the state to split the execution between two consecutive, from the perspective of a blockchain time. So the execution here would be able to pass on the results into a state and rely on the next state updates to have some additional conditional code branches that would either be active based on the calculated results and execute or not. Alongside of the code changes that we create and the system that we create as part of the MVP, we also focus on delivering the first attempt to present a user interface for composable execution. We see that the usability aspect is sometimes overlooked, and we would really like to provide a good way and a good insight to what's actually happening behind the scenes after we submit the smart contracts for execution, and also at the same time give nice tools for initial developers creating smart contracts with our systems to get their head around and really make the first nice attempts to creating the backbones of future composable smart contracts. So the first slide demonstrates how we could compose on one another, following operations that would happen into different consensus systems, into different chains. If you are wondering how does it happen that those operations are available to choose, the next slide should provide better insights into it. So this view demonstrates hypothetical projects that could be integrated with Tern. And on the horizontal line, we see the next platforms that offer series of operations that are available to be selected from. So at the same time, new projects integrate with Tern. Developers would give, while creating the smart contracts, developer would get the additional extra features to build the smart contracts out of. So far we learned a couple of things about the smart contracts with Tern. Now, in the last part of this presentation, I would like to overview quickly how does it happen that we can rely on the smart contracts being executed in a trustless way, following the Tern protocol. So the main architectural piece of the whole project we call Circuit. Circuit is nothing else but blockchain created with Substrate that is facilitating the fail-safe execution and becomes this dictator of execution protocol between all of the connected members of the circuit. It stores all of the smart contracts being able to be reused and executed, and at the same time acts like a judge for all of the proofs of side effects that will be transmitted into foreign consensus systems, and allows the whole validation logic to work in an open and trustless way, allows validators to join the system securely and also be the facilitators of the smart contracts execution. Sorry. Everything that is coming out of the gateway, which is the receiving end, which we call gateway. So gateway is for all of the systems that are willing to join Turn. It acts like a plugin for interoperability. So the system that is willing to install a gateway in some form automatically opens up to the wider blockchain traffic that comes from the cross-chain execution. And at the same time, being installed within the Turn ecosystem, developers could now select the features operating on this particular chain in their own smart contract. So it's sort of a win-win situation there. It's what physically the gateway could be. It really depends on the features of a consensus system it integrates. So for Ethereum, it could be external gateway being a form of a smart contract. For substrate-based projects, we also come with a palette that is able to receive the messages in a most trustless way. And at the same time, if the target chain doesn't present the chance for us to install anything there, we also can fall back to the simplest gateway that is relying on multi-signatures by our escrow accounts plugged into and being active in the Turn blockchain, and the security falls back into trust on the Turn ecosystem. The slides and the examples that you saw on the previous slides, they are all part of MVP alongside with the front end. So as part of the MVP that should be ready by the end of this year, we want to release the Circuit Give opportunity for developers to start experimenting and building out the first use cases of smart contracts. At the same time, we would like to introduce other projects and help build out the first integrations into Turn. What comes later is a focus on adding the more security, opening up the whole system to the escrow accounts that would then be able to bond their stake and take an active part in the smart contracts execution, with our overarching goal to become a Parachain slot. As a closing thought of my today's talk, I would like to display our mission. We believe in the trust-free collaboration, and therefore we create a system that allows developers to freely build and create the smart contracts in the way that is able to remunerate them for the original work. As a thank you note, I would like to invite you to join our community. As of yesterday, I believe we also opened up a Discord channel. About this, you can learn on our Telegram official site. And we also would love to welcome you into our development team, at the same time as welcome you into our first developer community building out smart contracts with Turn. Thank you so much.
Okay, thank you very much, Maciej. That was a really, really cool talk. I loved the level of abstraction you had in that in the code examples you gave. Just one question, and then we'll end. Is now ready to use? Like I know you said that the MVP would be out, but are there current versions that people can play with now, or is it not quite ready for them to use?
The short answer would be we would like to prepare all of the onboarding and documentation for the MVP to be ready, as mentioned, end of the year. Technically, it could be ready to start experimenting and building out these smart contracts since all of the architecture and palette pieces are there. But we are simply now in the process of verifying everything, covering up the missing links and pieces So yeah, it probably could be a pretty bumpy road for developers to start doing early experiments now. But we definitely are mindful of the fact that we would love to welcome developers and have it sort of like prepare the safe landing for them. So we have already started working on good documentation and the good sort of onboarding portal for developers.
Okay, great. Well, thank you very much. That was a very interesting presentation. And I'll ask everyone to just hold on for a few moments while we prepare for the next speaker. Welcome back, everyone. I'm happy to present Alex, who will be discussing Subsocial, the decentralized social networking system on Substrate. Alex?
Hi, Bill. Thank you for having me. Today, I'm a little bit sick, so don't mind if I will sound a little bit slow or, I don't know, lost. But let's talk about great use case of Substrate at our project. It's called Subsocial, and this is a social networking plus finance protocol built on top of Substrate blockchain framework. And let's start with a classic slide that talks about problems. So like why are we doing this? What are we trying to solve? And I would like to highlight 5 of most interesting and challenging problems that we are trying to solve. It includes global censorship, unfair monetization, monopoly on network effects, lack of customization for social networking, and algorithm dictatorship. I think I will get into some of them, not all of them. And let's start with unfair monetization. So everyone knows that on existing Web 2.0 social networks, such as YouTube, Patreon, Twitch, whatever. You have some number of monetization methods, like 2, 3, 4 methods. But if you look at DeFi, you can see that there are endless ways to be creative in terms of what monetization ways you could have. And we think that by utilizing blockchain and smart contracts, we could have endless ways of monetization for social networking as well. Next thing, let's talk about monopoly on network effects. This is a very important one as well, because social networks are very, very cornerstone of our communication online, and we use them every day, most of the people. And why they're so powerful? Because they own these network effects. And you can think that at one side we provided our data to these corporations, and from the other side we cannot fully utilize what we provided to them, and you need to ask access to get your data, and sometimes you cannot even get access to their API. Whereas if built on blockchain, like in our case, you already have open social networking graph out of the box that is permissionless, and anyone can have access to anything that is put there by users of this social network built on blockchain. And let's talk about last one. For example, again, let's get back to this API thing of social networks. So you can think like you can use API and build something alternative and maybe some sort of even competitor to existing social networks. But actually you cannot do it because they're kind of limiting access, rate limiting your requests, and they actually don't give us full spectrum of all the possible features of what they have on their side, on their backends. But in case with blockchains, again, it's blockchain is by default open permissionless system, right? And it's already has built-in API, and you can extend it with other tools like GraphQL and off-chain indexing and all this stuff. And it means that with Subsocial, you can build endless alternative user interfaces, backends to social networking, and build your own niche communities on top of open distributed permissionless social graph. Okay. I would like to say thank you to such organizations like Web3 Foundation and Parity, because they're very, very supportive to us and other teams, more than like 30, 40, I don't remember exactly, but in our case, we successfully applied and delivered 2 technical grants to Web3 Foundation. It consisted of 5 milestones, and most of the works you already see in working on Subsocial. So Subsocial consists of what we've done during this grants for Web3 Foundation. And also we are part of the first batch at Substrate Builders program, and this is very great and helpful initiative. We had a lot of webinars and special events and open and supportive chats for participants of Builders program. So if you have a chance to join it, I highly recommend to doing so. So lots of us already know such terms like DeFi, NFT, Metaverse, and so on. And I think that at Subsocial, we're kind of combining NFTs and DeFi and good old school social networking, but in decentralized way. So we call it SoFi. It means social finance. And one of the crucial elements of achieving this social finance future is that if you use social tokens, when every person, organization, or blog can have their social token optionally, of course, and by utilizing all the creativeness of smart contracts, we can get to the situation where we have everything we need on chain on the level of first-class citizens, such as your persona, your follower base, your assets, varying from posts to NFTs to avatar, whatever. And plus applying smart contracts and then tokens, you can monetize your activities, your user base, and your social graph. So among some of the core features of Subsocial I would like to highlight, such as we are building on Substrate. Of course, one of the killer features is upgradability. So whenever we develop, or if we want to develop new feature or improve existing one, we can easily upgrade our blockchain because of this killer feature of upgradability without forks of Substrate. Another cool thing that we have is Spaces. Spaces is like a blog or forum or subreddit or page on Facebook. So in our case, you have your own space, or even you can have multiple spaces. And such as we are on blockchain, and we have this multi-sigs and all that cool stuff, that you can think that your space as a DAO, and actually we're planning to allow issuing tokens there, and multi-sig addresses could own this space. So in this way, your classic kind of subreddit becomes DAO in case of Subsocial. Also following all this DAO and on-chain governance, we can have transparent moderation. So for example, in our case, we have developed such models for moderation where people can report inappropriate or illegal content that is not following rules of a particular space, and moderators of that space or owner can review this and block or allow this content. Also, we're using such things like roles and permissions, and for those of you who are using Discord heavily, you can find this kind of similar, so that you can create such interesting dynamic roles like editor of your space, or moderator, or contributor, whatever. So it's very configurable. So, and more classical components of social networking that is well known from Web 2.0 is again like spaces that is analog to blogs, and then each space can have multiple posts, and the post can have comments and upvotes and downvotes. And in our situation, we do it through blockchain. Of course, some of you can think that it's not optimal, but we always can improve architecture and introduce off-chain posting and combine it with on-chain, so then users can decide what way they want to go. And everything works on Substrate version 3. Right now, we're moving to the latest Substrate, and content such as images and titles of posts, text, body of post is stored on IPFS. On Substrate, we store just CIDs. This is a content identifier from IPFS. And one of the coolest feature, in my opinion, is that we don't have email plus password authentication. So on Subsocial, you log in just with your Substrate key pair. For example, you can log in via Polkadot JS extension. And it means that on Subsocial, you own your keys, you own your content, right? So also we extend functionality of Subsocial with off-chain features that is not very possible and optimized to do on blockchain, such as personalized feed and notifications based on what spaces or authors you follow, and full text search where you can search for content from post and space via using, like, for example, Elasticsearch. And also our web app that works on top of blockchain, it's search engine optimized. And it means that when Googlebot requests page, it is rendered on backend. Yeah, so this is a part of search engine optimization from server rendering of our web app. But at the same time, what is cool is that Subsocial web app can be running inside of just IPFS, and the only thing is required to be connected to Substrate node. So let's show some demo. Let's do it real quick. So this is how Subsocial looks like. It has such thing as a current account, So you can see who you're following, who are followers, editor profiles, check some roles if you have any editor roles on other spaces, for example. Also, you can switch between other accounts. For example, let's just check. So under Subsocial, I have this news feed, but I can easily switch to another account. Let's say this one. And then I have a little bit different feed. And of course, I have different notifications and balance. So for example, I can go to spaces and follow some space. Let's say I don't like anymore what Bill is writing about, and I can unfollow Bill. Yeah, so just wait for something about like 3 seconds on average. And now you have unfollowed Bill, right? But you still can go and see what Bill is writing here, and open commenting sections and upvote here. Again, very simple, just click of a button. Yeah, so we uploaded comment on Bill Laboon's post. And you can obviously go to other spaces like Subsocial and see, for example, follower base. Yeah, so we have a pretty big list of followers here. And yeah, you can also see what spaces you own. For example, if you go to my spaces, like these ones, something like subkitties. And yeah, what else? And of course, a very interesting one is that, for example, editors. If you go to Subsocial, for example, it has editor. You can click here, and you can see that Jan Biff is editor, and he can submit posts. So you can see that here is Jan Biff is writing posts, but sometime before Subsocial account wrote posts. So in this way, you can see that it's not just your blog; it's more like a subreddit, actually. Yeah. So I think this is quite enough for demo, and let's go back to slides. So if you look at more closely at Subsocial architecture, the main component is Substrate, of course. So it's a base layer, and we developed something about 15 modules for social networking, in addition to source modules palettes that are shipped with Substrate, and includes spaces, posts, follows, ownership, roles, permission, and so on. Also, quite an important component, but even this is optional. It's APFS, where we store images and contents of spaces, posts, and so on. And why I'm saying optional, because actually you can store your data in even like RV or even in private storage, and on Substrate you just need to store identifier to the content, and then web app or backend logic will resolve this data for you. Also, we use Postgres and Elasticsearch just to improve functionality with like full text search and notifications, because it's quite hard to get such reporting-like functionality from blockchain, because blockchain is more about key values kind of storages. And on top of it, of course, we have web applications that you just saw, and we are working on cross-platform mobile application in Flutter and Dart. Yeah, so as I mentioned, for Substrate, we developed quite a big list of social networking palettes, like spaces, posts, roles, and you can check them out in our repository. But I would like to say that one of the great things that allowed us to have quite understandable architecture and design of palettes is that you can couple them tightly and loosely. And there is a very great recipe on substrate.dev site called palette coupling. And by reading this recipe, you can understand how to make your palettes smaller that are responsible just for specific set of functionality, but then combine and interact one to each other in a nice way, like tightly or loosely coupled way. Also, at Subsocial, we use some standard approaches to have consistency through the code and understandability for developers. For example, usually we have such structs like post spaces, and then inside we have like ID and such field like created, updated to see who created at what block. And then we have such things like owner and content and hidden field. And for example, hidden field is responsible for soft delete because you cannot actually delete on blockchain without a trace, but you can sort of recommend to end user interfaces. So please don't show this content because our author owner don't want to show it. Also, regarding storages, how we work with them in Substrate, usually we have this approach where we have maps. For example, by ID or by space ID, you can have its owner. By owner of a space, you can have a list of space IDs. Then, let's say by space ID, you can get details of a space. And then by post ID, you can have a list of reply IDs. Actually, it's vector in Rust. And by space ID, you can have a list of root posts IDs in that space. So that by using this approach with maps, you can easily have tree-like structure where you get by IDs some details, or by parent ID, the children IDs. And again, as I mentioned earlier, that we use some off-chain logic is thanks to such technologies like subsquid.io or subquery.network. You can subscribe to your substrate events in off-chain. For example, in our case, we subscribe to this list of events like account followed, unfollowed, space created, updated, and so on. And then based on these events, we fulfill Postgres database and Elasticsearch, and then users can have their personalized feed, notifications, full text search, and all this cool stuff that is not easily achievable on a blockchain. Also, a very cool thing that is possible with Substrate is fee-less transaction. We're still in development of this feature because it should be developed quite carefully, because if developed wrong, then your blockchain could be DDoSed. But if developed correctly, users can have free transactions, for example, based on amount of tokens of your protocol locked for 1 month, let's say. And this will be a great user experience improvement. About free transactions, you can watch this YouTube video with Sean Tabrizi and read his and check out his fork of Substrate developer, Substrate template. Also, we're working on Flutter SDK. This is a framework from Google for creating cross-mobile applications. Currently, we developed read-only functionality and working on current user, such as like create import account, sign off transactions, but we have already working application not yet published, and this application works via foreign function interface. It calls code written in Rust, and it works with SubXT library that knows how to get data and send data from blockchain. So it's very cool. And if you want to check out what we have, just visit this link on GitHub/dubforce. This is our company. Also, we have such interesting tool that we developed quite recently. It's called SubID, and this with SubID you can see a very interesting feature of Substrate is that even if addresses look differently, all of them are derivable one from each other because of Substrate nature of addresses. And this is very cool because you can go to you can get any account. Let's say I have opened actually Bill Laboon over here, and you can see public portfolio. So it's like decentralized public portfolio manager explorer. You can see like pie chart with locked free balances. You can see contributions to crowd loans, and again, you can see them in a chart way. You can even unpin something of this. You can see assets from StateMine, not all of them, but some that are most popular. And of course, you can see your favorite birds if you have. I think here you can see some birds, right, on Raul account. Yeah, and yeah, so we are a relatively small team, under 10 people, and we are hiring. So if you're interested to build a decentralized social networking with on-chain finance, and you would like to join us, so just message us on Twitter or in our chats. And here are our links. Thank you for listening to me.
All right, thank you very much, Alex, although I was a little upset that you unfollowed me.
Just one.
That's fine. Just one question. So I know that there's a direct connection with your Polkadot account or Kusama account. Is there any thoughts of also integrating decentralized identity solutions, of which there are several in the Polkadot ecosystem?
Yeah, are you talking about something like Guild?
Yes.
Yeah, actually, we even discussed. We already had a couple of calls with them, and we're in good contact. And we are very, very interested. But for example, Guild was very, very busy with Parachains through this year, and now after Parachains, some also work should be done on their side, and on our side we have tons of things to work on. But in short, yes, we're super, super interested to add support for decentralized identities. Yeah, it's true.
Okay. All right. Thank you. I see there are a lot of other questions in the chat. So please, go to the Discord, or you definitely can see Alex and team in the community quite often. So thank you again, Alex. That was a very, very great presentation. And now let's just take a few moments while we prepare for the next speaker. Welcome back, everyone. For the last presentation of the evening, we have Sean Tabrizi discussing the gift secret. Sean?
Yeah, hey, thanks, Bill. First, I want to say hi to everyone. And wow, like today has been a packed day. I mean, I'm looking at the schedule right now. There was the keynotes all about parachains, light clients, bridges, smart contracts, ton of ecosystem stuff. I mean, all these different builders. It's like, if you've been following along and you're not sweating, geez, good for you. Also, big shout out to Bill. I mean, Bill has been such a crazy host. Like I'm seeing like, Bill, you're actually forming a small cult inside of chat. So if you're part of the Bill cult, definitely type Bill in the chat. But you've been an awesome host. And so I'm really glad to be here at the end of the day. Yeah, today I'm going to be sharing with you the gift secret, or basically this idea of like Polkadot Gifts. And so what is it? So Polkadot Gifts is basically a web application built on top of Polkadot, which makes it as easy as ever to be able to send dots to your friends and family who may not even have a Polkadot account yet. We all know that like, Polkadot is one of the most advanced blockchain platforms out there, but to be honest, we still have quite a way to go before we make it dead simple and easy for new users to onboard. And so the goal of Polkadot Gifts is to try to provide a dedicated and streamlined experience to connect existing dot holders to be able to transfer to new accounts, new users of the network. And really, there's no better time to set something like this up than now, because we have auctions announced. We have all these crowd loans that we want people to participate in. We have the holiday season, like, sending dot as a gift is really, there's no better time than now to do it. And we want to show you kind of how easy it is to use Polkadot Gifts. And it's really as simple as kind of 1, 2, 3. So I'll be walking through all of the steps here and kind of showing you how you can create a gift and, share kind of the dot love to your friends and family. Okay, so I'm going to start on the main homepage where we're able to generate a new gift. And you can see here, I can simply click send a gift. In order to send a gift, of course, I need to have some dot to begin with. I can connect a ledger or Parity signer, but I'll be using Polkadot extension to start with. And then I can select my account, connect, and then I can type some information. So this recipient is Sub0, and the amount I'll be sending 5 dot. Okay, so I'll click next. And then basically I can confirm of the details of what I'm about to send. I'm going to store this secret in a safe spot. I'll be storing it here. This is, by the way, you don't actually do what I'm doing here. Obviously, this is not very safe on a public video chat, but let's go ahead and have some fun anyway. And then I'm going to sign this message. Okay, so now I'm going to be generating a gift on Polkadot. And then you can see after the gift is generated, we have this nice little message. We can copy the message and we can send it to our friends and family, basically whatever we want. So whether it be a text message, direct message, even an email, or even if you want to print out this this kind of message, or create your own message and give it as a gift, you can do that too. But basically, once you have this, you're ready to go ahead and send the gift. Once the user has received the gift, let's imagine now I've received this awesome gift. I'm going to follow this link to claim. Okay, connects to Polkadot. Okay, so of course you can connect an existing account. So if you already have an account with a Polkadot extension or Parity signer, or even if you want to enter an address manually, if you don't even have to connect your account to this to be able to receive the gift, you can go ahead and do that. But for our scenario, we're going to be imagining that I need to create a brand new account. Okay, so I'm going to go ahead and create a new account. And of course, again, don't do as I am doing, do what I say here, which is that you should be saving this account, kind of back it up in an offline method, usually write it down on a piece of paper. But of course, for this example, I'm just going to make things a little bit simple. I'm going to be copying and pasting this so I have access to it later. Okay. And then I've stored it in a safe space. Obviously, don't do what I'm doing, but I'm sure you all can follow the best practices of saving a new key. And I'm going to verify, of course, that I have backed it up. So word 1 is mix. Word 9 is output. Okay, let's verify the phrase. And then, of course, you can create a JSON backup. So you don't have to, type in this seed phrase every time you want to use your account. You can actually just create a JSON backup. So this is gift example. And then I can have this JSON backup, which then can be easily imported into things like the Polkadot.js apps or the browser extension. And of course, I'm going to now copy my gift code, basically a nice little code, claim the gift. Ooh, and someone may have already snatched it from underneath me. That's perfectly fine. But basically, yeah, once you've claimed your gift, actually I have, and I've prepared for this actually. I have another gift secret, which I've written down just in case someone was gonna steal it from me. 14953964189518880. That's good though. You all are paying attention here. But I'll be transferring the gift to my account. And then of course, now I have this gift into my new account. I can see the account here. Okay. Yep, and this account seed is also available. So the next person to select that one can also have it too. But yeah, basically you can see here, it's really, really dead simple and easy to be able to invite new users, to be able to get DOT. You know, they don't even need to have an existing account. You can go ahead and create a gift and share it with your friends and family. So what's happening in the background? So let's make sure that people don't feel afraid that someone else sniped my gift. Obviously, if I'm doing everything public, you know, this is gonna happen. But what's happening in the background basically is that when we create a new gift, and we generate this gift secret, this code, we're actually creating a brand new Polkadot account. And that code actually represents the private key to that account. And so when you generate that account, only you, the person who created the gift, and the person who you send the gift to will have that key. So you will both be in control of basically like a middle account. Once you've shared the gift and the user claims the gift, they of course will go through the process of creating their own brand new account. And they will go ahead and claim that and move those funds from the middle intermediary account into their own account, which of course you or no one else should have access to except that user. So for a little bit of time, we have this intermediate account where both people can have control, and then we can permissionlessly allow people to transfer the funds out of that account into their own custom account. And basically the idea around all of this is that using this method, one, we don't have to use any custom palettes or any custom logic. Two, it's completely permissionless, trustless, and secure. And if your friend doesn't claim the gift for whatever reason, you know, they didn't want to use it, or they couldn't, you know, they didn't get your message, you can always go back, check the gift, and because you have access to that gift secret, you can always, you know, return the gift to yourself. And so basically the idea here is that, you know, you can go ahead and invite users into the Polkadot ecosystem in a really easy way, and use the gift app. Yeah, so we have, just go to gifts.polkadot.network. We also have one for Kusama at gifts.kusama.network. And you can go ahead, of course, if you have a substrate-based blockchain, or if you're doing any, you know, kind of parachain, again, because we don't use any palettes, because this is kind of, you know, kind of an abstract concept for any substrate chain, you can go ahead and actually even fork this repository and build this entire end-to-end experience on your blockchain as well. And so, that is it. I hope you all had a really great first day, and I'll be taking any questions if there are any. I wonder if anyone already got that account. Yeah, go ahead.
Yeah, I don't know if anyone has admitted that they were the ones who took the DOT. But they were quite fast on the. Yeah,
but I'm prepared. That was the whole point. The whole goal of this actually end to end was to give away 2 gifts here for myself. So you're welcome to both of you all.
Okay. Yeah, so we actually don't really have any questions for you, but I think that
that's awesome. Yeah.
Yeah, it was a really great presentation.
I guess I'll mention this. You know, we can see the activity of gifts and people using gifts, and I wouldn't be surprised if you might see some airdrops or some other types of, you know, small rewards or something like that given to people who are able to you know, give gifts to other people and get those users to actually use the network. So, you know, things like giving a gift to your friends and family and having that user vote in the next democracy. People even vote right now to accept the next auctions in democracy. Those kinds of behaviors we can actually see on chain, right? And so you know, I wouldn't be surprised if we keep an eye on that and find a nice way to reward those who grow the community.
Oh, interesting. We actually did get some questions. First, will this work with state mine assets?
Yeah. So again, this is so actually we actually used this exact same platform recently to do to help facilitate an NFT giveaway on Kusama. I'm not sure if people are familiar with that, but actually what happens in the background here is that we will check in the gift account, you can fill it up with any NFTs, fill it up with any statement assets, or any you know, native tokens. And when you actually when you actually go to claim the gift, all of those different tokens will all be transferred to the next account. So we'll actually batch in one transfer all of the NFTs, all the things. So you can imagine filling this gift box with a bunch of different cool things and then sending that over.
Oh, okay. Great. So one other question. Wow, we're actually getting lots of questions now. I guess it just took time for people to type. So when you actually do the gift, what will you see on chain? Will you see the transfer to this intermediary account and then a second transfer, or like how would you notice a gift?
Yeah, nothing here is super magical. What we're looking to do to notice a gift specifically is that we're planning on having a remark attached to this website. So when you submit a gift, we might have a remark that says, hey, this is a gift, which can identify basically a gift versus other kinds of normal transfers. And that's just a hint. Obviously, nothing is 100% known. We're not actually tracking any data. So one thing to note is that this website is completely stateless. So we have no information about who creates gifts, what gifts, amounts, whatever, all that kind of stuff, other than the fact that, there's some kind of hints on chain, in any public way that, would be normal. And then, of course, we can take a look at that history and see kind of what the users who received the gift did, or, whatever. Again, there's no promises here, but, I'm just saying that this is something that we would love to help encourage you and your friends and families to go ahead and actually give gifts.
Another question. Is it possible to set an expiration time for the gift?
Unfortunately, currently, no, because we don't use any custom like palettes or anything like that, and because things are completely stateless. Obviously, we can't, track and automatically rescind a gift. But what you can do is you can of course put a reminder for yourself, and of course hold on to that gift secret, and then get rid of it after a certain amount of time. But yeah, I mean these kinds of secondary types of automation that can definitely be programmed on top of the blockchain. But we're not providing any of that right now. What we want to do is keep a very clean, streamlined, and safe system for users to use.
Yeah, that makes a lot of sense. Okay, well, thank you very much, Sean. That was a really cool presentation and a very rewarding one for some people out there that were able to
users out there,
grab the gifts. Yeah. All right. Well, again, thank you very much. I appreciate it, and thank you also for having getting people to write Bill a bunch of times in the chat. I appreciate it.
You earned that one, Bill. Okay. See ya.
Thanks. All right. Well, that concludes our presentations for the day. We will, of course, be coming back tomorrow with 3 stages: beginner, intermediate, and advanced, for people to learn more about Substrate based on their individual level. So after we end this, of course, there will be networking. So please just click on the networking tab in Hopin, and I will see you tomorrow if you are part of the intermediate stage. All right. Have a good evening.
Thank you.